Allora, possiamo intanto cominciare, tra poco penso che parta anche la diretta e cominciamo subito col panel, quello un po' più sostanzioso, diciamo. Sicuramente avremo una bella discussione, insomma, ci aspetta, sicuramente sono temi molto interessanti. Quindi senza rubare altro tempo lascio subito la parola all'introduzione. Cerchiamo di fare come ieri, di mantenere la tempistica. Perfetto, grazie.
Good morning, everyone. So the organization of the panel dedicated to electronic publishing and open science in archaeology is part of a 10 years course of activities carried out within CNR aimed at monitoring the status and evolution of digital publications, with particular regard to open access electronic journals and open science in antiquities. Today, the dissemination of the results of archaeological research is still primarily associated with publications, monographs, miscellaneous volumes, but above all, specialized journals. These have experienced in recent years a progressively digitization process, which resulted in an increasing availability of open access resources, even if the policies adopted for the digital fruition use different forms of access to articles and their contents. It is a process that will certainly continue its evolution, especially in consideration of the recent National Plan for Open Science, published in June by the Ministero dell'Università e della Ricerca. A document that, in line with current European trends, also moves toward the rapid dissemination of research results based on online digital technologies. Nowadays, data communication in archaeology exploits also channels others than traditional publications, thanks to the growing and massive digitization process and the availability of increasingly sophisticated technologies, which provide archaeologists with very powerful research and communication tools. The second objective of the panel is therefore to present some example of data dissemination channels frequented by archaeologists, also with a view to engaging and participatory communication. The papers we are going to hear will therefore show different cases of these issues, testifying a panorama of dynamic planning and multiple initiatives. The organization of the speeches follows an order that starts with the presentation of some times of open publication and then moves to aspects of visual enhancement, now a key element of many archaeological projects. We start from two international papers. The first one belongs to the French field of studies, which has been an important reference for years regarding open science initiatives. The subject is the gradual transition of print archaeological journals to new models of online scholarly publishing, as well as the economic and organizational tools that guarantee the sustainability of these models. The second one concerns the peer community in project, which offers an innovative way of communicating scientific results, free, open, online, and peer-reviewed. We would like to thank the online and in-person speakers and the meeting organizers, in particular Julian, and we wish everyone a good work. So we start, Virginie from ArcheoFOSS and Gaël Cougagnon on the road to open up.
Good morning, can you hear us?
Yes, perfectly.
Okay.
Good morning.
And the presentation.
I should have a copy if you are having issues on sharing your screen.
We try it ourselves.
Okay.
Okay, we are pleased to join you online today from Nanterre. Is it visible? It's okay?
Everything okay, thank you.
Thank you. And we wish to thank the organizers of ArcheoFOSS for this wonderful program of reflection. I'm a data manager in CNRS, specialized in digital databases and publishing. Now, Gaël.
So, and I am Gaëlle Coquignon, so I'm editorial engineer at CNRS and assistant head of the pôle éditorial, the editorial department of the Maison des Sciences de l'Homme Monde, where I am editing 2 journals in archaeology and ancient history, Revue Archéologique and CIA. Our 2 research units are both based in the campus of Nanterre, and collaborative discussions between the numerous professionals based there give us a precious glimpse at the evolutions of practices in terms of data management and publication in a context of open science, where scholarly publications and data tend to be open more widely and faster. This is these evolutions encouraged by European and more particularly French institutions we want to present quickly here through examples coming from our units. Let's begin with a look at scholarly journals in archaeology prepared in the pôle éditorial of the Maison des Sciences de l'Homme Monde, the former Maison Archéologie et Ethnologie René Ginouvès. We are a cluster of a dozen editorial engineers from CNRS in charge of the editorial support and preparation of publications in humanities and social sciences, mainly journals. Each member of the staff is assigned to work for 1 or 2 scholarly journals as part of the support given by the Institute of Humanities and Social Sciences of CNRS to scholarly publishing, and to these journals in particular. In exchange, the journals are committed towards the development and application of virtuous editorial practices and policies, among which open science holds a major, if not a central place. 9 of the journals prepared in the unit are focusing on archaeology, either prehistorical, classical, or American. While all of them are now available online, completely digitally compatible and engaged into the road to open access, they correspond to different economic models and follow different paths towards open science. These differences are partially linked to a great diversity in their history, with creation dates ranging from 1844 to 2016, and an engagement in digital diffusion more or less recent, since the 2000s for some journals, while others gained a digital version in the late 2010s and early 2020s. To this history are also linked the status of the journals, their partnerships, and their choices in terms of diffusion. Among the archaeology journals in the pôle éditorial, we can find almost all the range of scholarly journal diffusion possible today, excluding those still exclusively in print. And on the other end of the spectrum, the preprint journals, which our colleagues of Bordeaux will, I think, speak about later this morning. This includes journals linked to public or private publishing houses, or to scholarly learned societies, available in both print and digital versions. You can see them on the top of the screen, or born digital only journals that you can see on the bottom of the screen. The digital version can be hosted by scholarly platforms like Cairn and Open Edition journals, or on their own website. The issues predating the 2000s are generally available in 1 or more platforms, on the subscription platform Gestor, or fully on the platform per se, or on the institutional archive HAL. The archaeological journals of our panel are also present a diversity in their degree of openness and the economic model they follow, from subscription journals to journals giving free open access only to their previous issues, to a more immediate open access of various kinds, either green open access, that is the deposit of the preprint version of the articles on the institution archive HAL as soon as the volume is published, or Diamond Open Access, which provides readers with immediate free access to the edited text without charging the authors with APC fees. Institutional incentives and requirements have resulted in a steep acceleration in the last decade of the process toward a faster opening of the journal contents, and more particularly towards the Diamond model, encouraged by current European and French governmental policies, as can be seen in the case of the journal Syria, which progressively reduced its period of embargo before open access release on Open Edition Journal from 2 years in 2018 to 1 year in 2021, and finally abandoned it completely this summer to adopt the Diamond freemium model. Another almost simultaneous transformation of archaeological journals has emerged and been made easier by the adoption of digitally native editorial processes, which allow a greater interactivity within the journals and in the scholarly world as a whole. The increased importance and time devoted to the association of metadata in the editorial preparation are a first result of the digitally thought process, such as the careful choice of keywords which allow to link articles within a larger scholarly ecosystem. It also helps the development of new models of publications in the digital versions of journals, including additional material previously difficult to include in print, such as 3D photos or large sets of data. Indeed, the association between publication and sets of data is now facilitated and even encouraged, as can be seen in this example from the journal Gallia. On the left, you can see the digital version of an article on Open Edition Journal. The digital format allows to associate to this over 70 pages long synthesis different sets of data, which would traditionally have been excluded in a journal, necessarily limited in terms of space. Here, several appendices were thought as an integral part of the publication and directly associated to the main text via a link at the end of the article, leading to a website and to another platform hosting them, Nakala, on the right, that you can see on the right part of the screen. Of course, this kind of data sets are not new practices in themselves, but they were rarely included in journals and not easily searchable in their print form, despite several attempts and experiences in the 20th century.
Thank you, Gail. And after the cutting-edge methodology in publishing, let me introduce the legacy of the former generation. My part of the presentation deals with a case study based on 2 bibliographies published in review articles, providing a systematic and critical analysis of literature in a given field. They have been published for almost 30 years in the French printed journal, the Revue Archeologique, one of the journals mentioned by Gaël, and you have the collection of our library on the screen. The first bibliography contains contributions on the topic of architecture in ancient Greece, the Temple of Paestum, and the project leader, Marie-Christine Hellman, on the photo, specialist of classical architecture, passed away in December 2017, has worked on the analytical bulletin on the architecture of the Greek world. She managed the task of coordinating this publication by collecting over 400 reviews written by 30 experts and published every 2 years in the journal. You can see a scan of the first page of the publication and the list of contributors, a little cooperation. There is no need to stress the difficulties of this kind of collaboration. Finally, she had done the job alone. The other bibliography aims to discover review articles in the field of Greco-Roman glass. The author, Marie-Dominique Nénat, on the photo, has studied glass and Egyptian faience collections in many museums. You see here a cup with an erotic scene from the collection of the Corning Museum, and she led excavations in Egypt in search of glass workshops. Here in Wadi Natroun, she created the review articles to draw the attention on the development of these studies and to help the specialists of various areas which didn't have an easy access to publication. She has done the job by herself for 14 years. So it's for the past practice of reviewing thematic bibliography. Now I'm going to the databases. Anne-Marie Guimier-Sorbet is an archaeologist and was a specialist of archaeological databases in 80s and 90s. She worked closely with Paola Moschetti, you know very well. She had the idea that both printed articles and web databases should be elaborated in parallel. So databases have been designed and distributed online for almost 15 years. You can access online in free access. The publisher, Les Presses Universitaires de France, accepted this principle. The thematic articles I have shown were taken over after Marie-Christine and Marido, so each website has become an archive. You see on the screen the homepage of the two websites. The web databases are still hosted on the university server with the solution MySQL PHP, initially designed by her IT staff. The user can ask in a search box types like round altar or luxury blown glass in French, and he gets all the records in the database, which are associated with that subject field. But the disappearance of our IT department for scientific programs leads us to look for the transition onto a common platform. Humanum is a French public research infrastructure with international reach devoted to social sciences and humanities. We already have a copy of everything on their servers. You see on the screen the set of our system, but we are urgently looking for ways to update the setup file and the PHP scripts. We are still facing problems that we are trying to solve depending on availability of external IT specialists. So we are thinking to a low-tech proposal. We could export all data in a text-structured format and make it available in a repository. You can see on the slide models made by French colleagues. On the left, a dataset deposited on Nakala, a Humanum's platform already used by online journal mentioned by Gaël. On the right, a data management plan template created by other colleagues, useful to develop a background presentation of the databases with precise metadata. We think actually that the limits between online journals and databases archiving tend to blur, and we hope to develop this idea further together. At that time, when the libraries of retired researchers are being donated and integrated into our institutional library, it is important to do the same for the databases. We are engaged in seeking ways to preserve these samples for two reasons. In one hand, the bibliography exists over a long period of time, and in the other hand, that kind of contributions are disappearing from printed journals. So thank you for your attention, and you have some links on the screen. That was my conclusion.
Okay. So now sono online anche loro. Sì, sì. Alain Kefelet, Marta Arzarello, Ruth Blasco, Otis Crandall, Luke Loyon, Cian Alcrow, Emma Caroon, Bruno Murray, Heitor Ruiz Redondo, Philip Vampire. Peer community in archaeology, a community-driven, free and transparent system for preprints per reviewing.
Thank you. Hello, everyone. I hope you hear me well.
Yes, perfectly.
Great. No, it's not this one. I think this is, yeah. Is it okay? Okay, so I will present in the name of the managing board of Peer Community In this free and transparent initiative for preprint peer reviewing. So as you probably know, the context for the main present system of publication is publications behind paywalls, publications in open access with APCs or hybrid journals, which of course are the worst. Of course, we also know a lot of diamond journals. In this system, the publication of one paper is very expensive, and it costs 3,000 euros per paper in the worldwide cost of academic publishing. These costs are abusive, as you can see on the left. The operating profit margin of the big main 4 publishers is really high and is even higher than any leading companies in any field in economy. And these profits are rising, and it becomes the total French CNRS annual budget of 2.6 billion euros is the benefits of the group owning Elsevier. So there is another way to publish, which has been used by physicists, mathematicians, biologists, etc. for years. And it is just starting in archaeology, and it's preprints. So you can put your preprints on different online servers. And this only costs something around 10 euros per paper. The main problem of preprints, of course, is that it lacks peer reviewing, and that's the goal of Peer Community In. So Peer Community In is a French association, and it created several communities of researchers in different scientific domains, like evolutionary biology at first, and then ecology, paleontology, etc. This system allows completely free for authors and readers, no APC, no paywall, no delay, no subscription. It also imposes open data and open code. So how does this work? So the first step is for the authors to put on the preprint server their manuscript, and also to share on any online repository their data, scripts, codes, etc. When this is done on the preprint servers they chose, they come to the PCI website and they submit it like they would submit in a journal, but it's way simpler since you just have to put the link on the cover letter. We have a pool of recommenders. We call them recommenders. They have the same role as
some connection issues.
a recommender will handle the preprint and will invite reviewers, and the peer review process will be as usual with different versions of the manuscript, or still put on the preprint server if necessary. Of course, at the end of the peer review process, the preprint can be rejected, and if it's rejected, nothing will be published on our side. The preprint can still remain on the preprint server, of course. If the paper is finally recommended, the recommender will write a recommendation, which is a short text like news and views, and will explain why the paper is interesting for the community. And the authors will put a final version of the preprint on the preprint server. the recommendation, the reviews, the answers to reviews, the editorial decisions of the different round of reviews will be published on our website and given a DOI. After this paper being recommended, of course, this was the main goal of PCI in the first place. It was to have recommended preprints online, and in the end, this is all we need for good science. But we also know that authors need to fill in their CV because they have to ask for funding, they have to ask for their career, etc. So now we propose several solutions to have a more traditional publication after the recommendation process. One of the solutions is to directly push the paper into the peer community journal, which is a new Diamond Open Access journal, a generalist journal. And there is a part of the journal dedicated to archaeology. And if you have your paper recommended by PCI Archeology, it will be automatically accepted as is by the peer community journal. There are also a list of PCI-friendly journals. Some of them accept with no further peer review, since they can see the peer review process on our website. Most of them will give you a fast answer if the paper is in their scope, if they will send it for another round of review or not, etc. And so the authors can make their decision quickly, knowing if the paper will be published as is or with a new round of review, etc. And of course, authors are free with their preprint to submit it to any journal they want. With all this system, with the several years that the PCI system already exists, they have calculated that the final cost of the recommended paper is something around 150 euros. The peer community in is supported by many institutions in France, of course, but also in Europe and worldwide. These institutions support the initiative, sometimes with fundings, but sometimes only with an institutional support. So now let's talk a bit about PCI archaeology more precisely. We are a team of 107 recommenders today. They are highly specialized recommenders. We want to have many recommenders so that we can share the workload, because we know that, for example, in traditional journal, the work of associate editor or editor is a very heavy workload. So we want to share it. And we also want to share the power of editorial scientific decisions among many people, so that it's not one or two people deciding for a field of research. These recommenders are senior researchers, mid-career researchers, and also early career researchers. We have a still too high proportion of French people because, of course, at the beginning, it was way easier to find French colleagues and to ask them to become recommenders. But now we are hiring only, mostly only not French recommenders. And we try to have a good ratio between men and women. The recommenders have a lot of expertise. As you can see here, we try to have specialists of every kind of discipline in archaeology. But as for the French proportion, it's also easier to find a Paleolithic specialist. Being myself a Paleolithician, it's easier to find specialists that I know. For we created PCI Archeology in 2020, and we received 10 submissions this year, 11 in 2021, and already 10 in 2022. As you can see, there are also 7 submissions still in progress. The number of reviewers for each preprint is quite high, since we try to invite many people. Of course, as for any journal, it's quite difficult to find reviewers, but we think that given the fact that we are free and open access, we find reviewers a bit more easily than traditional journals, since people know that their time is not to give money to Elsevier or Springer. We also try to have a quite short length to first decision, but of course we also are researcher ourselves, and we don't want to put too much pressure on our colleagues, because we know we all face a lot of delays every day, a lot of deadlines, etc. So the list of PCI archaeology friendly journals, it's only not-for-profit journals, diamond journals, or if they are published by publishers, it's only journal owned by learning societies, so that at least part of the money go back to science. So you can see here that in 2022, 2 new journals joined the list of PCI friendly journals. Here we can see the fate of the recommended preprints so far. So as you can see, 4 papers were published directly in peer community journal. For the 2 papers were submitted to +1. One was published as is with no further peer review, and the other one was sent to a supplementary round of peer review because the editor didn't know PCI archaeology. So we try to have contacts with these journals. You can see that there is quite different journals implied here. So we think at PCI archaeology that we need for good science, free science, which is peer-reviewed, which is open and reproducible, and we try to offer that to the community. So what can you do as potential authors? You can, of course, submit your next paper to PCI archaeology. Please review if we contact you. It's still very difficult to find reviewers. You can also endorse these papers by considering them valuable science and citing them, and also try to find maybe support through institutional committees or through your university, etc. And of course, the most important thing is to spread the word to your colleagues. So I remain to thank you for the invitation for the Congress, and you can find this slide at the link on the slide. Thank you.
Allora Marco, contiamo là. Va bene, sì, alla Bellotti. Ok. Allora proseguiamo online. Ci sono?
We'll try to make a change if Bellotti et al. It's available. Okay. So we have all the online part together. Okay, thank you, Luca.
Andrea Bellotti, Luca Lupino, Maria Messineo, Niki Scarcella, Spring Archeology e Gathering Project of Emerging Researches.
Ok. Confermatemi che si vede la presentazione. So I apologize with my foreign colleagues because we prepared my speech in Italian, but the slides are in English, so I think there will be no problem. So, buongiorno a tutti. Intanto inizio con il ringraziare anche a nome dei coautori Andrea Bellotti, Maria Messineo e Niki Scarcella, tutti gli organizzatori, il comitato scientifico di ArcheoFOSS per l'opportunità che ci avete fornito di presentare la nostra esperienza e i nostri progetti anche futuri, in un contesto come questo che molto somiglia a Spring Archeology. Cos'è Spring Archeology e come nasce? L'idea originaria di un convegno che un po' si rivolgesse a dei giovani studenti e organizzato da giovani ricercatori e studenti circolava già nel 2015, diciamo, nelle aule dell'Università di Siena, nel Dipartimento di Archeologia, con l'esigenza di offrire a appunto giovani ricercatori, studenti, ma anche professionisti del settore un'occasione per presentare i loro lavori e avere anche la possibilità di pubblicarne i dati, vista anche un po' la difficoltà spesso di riuscire a trovare uno sbocco per condividere le proprie ricerche. L'idea era sì, appunto, quella di realizzare un vero e proprio convegno, un po' nella sua forma classica, ma così come ArcheoFOSS, l'obiettivo principale era quello di creare e costruire una comunità che, diciamo, avesse come obiettivo centrale l'accesso illimitato e pubblico ai dati presentati. E con questo, indirizzando, come ho già detto, principalmente il convegno ai giovani ricercatori, finanche agli studenti in possesso di laurea triennale, quindi dei neo-ricercatori, avere la possibilità anche di dare un po' un punto di vista sull'attualità della ricerca archeologica, avendo quasi facendo di Spring Archaeology una cartina tornasole dello stato di salute dell'archeologia in Italia principalmente e delle sue prospettive di sviluppo. Nel 2020 nasce così Spring Archeology 2020, organizzato, questo va detto, grazie al contributo dell'Università degli Studi di Siena e con il patrocinio del Dipartimento di Scienze Storiche e dei Beni Culturali e delle principali associazioni di categoria, che in questa sua prima edizione riuscirà a raggiungere appunto 68 autori fra autori e posters, che, diciamo, non sta a me dirlo, ma a parer nostro rappresenta comunque un ottimo risultato per un neonato convegno. Il convegno viene pensato, appunto, come dicevo prima, per una versione classica, quindi in presenza e nelle aule del Dipartimento, seppur già con in mente la possibilità di avere uno streaming online degli interventi. Il tutto però viene stravolto dall'arrivo della pandemia da Covid-19, che ci costringe a migrare sul web, organizzando 3 giorni di live streaming del tutto simile a quella a cui stiamo partecipando adesso, appunto su YouTube, dedicata alla presentazione dei papers, alla presentazione dei diversi panel che erano stati programmati e alla tavola rotonda finale, che poi avrebbe tirato un po' le fila del convegno, e una sezione invece sul sito del convegno dedicata alla presentazione dei posters che appunto erano stati presentati, ma non avendo la possibilità di essere appunto stampati, sono stati organizzati all'interno del sito. Tutto ciò è stato possibile grazie alla collaborazione con Let's Dig Again, alcuni di voi forse la conosceranno, la prima web radio archeologica in Italia, che si è occupata appunto della messa in onda del convegno e di tutto l'aspetto comunicativo. Diciamo, questa un po' emergenza ha avuto sì dei lati negativi, che in realtà un po' si sono risolti. Primo fra tutti era appunto quello di fare rete, quindi mettersi in contatto diretto con tutti gli autori, ma questo, diciamo, il fatto di spostarsi online non ha fermato questa voglia di contatto, di mettersi appunto in rete, perché appunto siamo ancora in contatto con molti autori e molti autori si sono incontrati grazie a Spring Archaeology e collaborano tutt'oggi. In tutto ciò c'è anche però un punto di vista molto positivo, cioè la visibilità del convegno. Per un convegno nato e organizzato, diciamo, in poco tempo da giovani ricercatori, è un po' defilato rispetto a dei grossi convegni che sono presenti in Italia, prima fra tutti. Comunque abbiamo raggiunto dell'ottima visibilità, circa 5.000 visualizzazioni totali e 2.600 spettatori unici. Questo vuol dire che siamo riusciti a raggiungere 2.600 diversi utenti online che hanno aperto le dirette YouTube e hanno dimostrato un interesse negli argomenti trattati, rispecchiando un po' il potenziale della trasmissione online dell'evento, appunto, e la possibilità, un po' anche la comodità di poter partecipare sia da parte degli spettatori, ma anche di relatori che comodamente, seppur costretti a casa, hanno potuto prendere parte senza problemi al convegno. Un altro problema che si era posto era l'interazione tra gli spettatori e gli autori. Questa interazione però è stata anche, secondo noi, facilitata dalla chat, da una live chat sempre presente, e grazie all'intervento dei moderatori è stato possibile mettere in relazione, un po' mettere in contatto appunto gli autori con il pubblico. Data la natura open di Spring Archeology, la naturale prosecuzione era appunto la pubblicazione degli atti in modalità open access. Ci siamo affidati alla casa editrice ArcheoPress all'interno della collana Access Archeology, e questo, un po' come diceva l'intervento prima di me, ha abbassato notevolmente i costi di pubblicazione. La peer review è stata affidata a un comitato scientifico composto da giovani ricercatori dell'ambito dell'Università senese, coordinati da docenti sempre dell'Ateneo senese, e poi tutta la fase di revisione e pubblicazione è stata invece gestita dagli organizzatori stessi. Questo per quanto riguarda sia i testi relativi ai papers che relativi ai poster. Per quanto riguarda i poster, sono stati organizzati degli ulteriori interventi non in diretta sul canale YouTube, ma è stato chiesto appunto agli autori di realizzare dei piccoli video da caricare sul sito del convegno, così da dare loro la possibilità di avere più visibilità e di presentare il proprio poster come se fossero stati in presenza di fianco alla stampa dei loro contenuti. Con diciamo, gli ottimi risultati ci hanno invogliato a continuare sulla strada dell'aggiornamento, appunto di anche tenere insieme questa rete che si era costruita grazie ai cosiddetti Springs Update, cioè una serie di mini conferenze che abbiamo organizzato durante tutto l'anno successivo e anche i primi mesi del 2022 con gli autori che volevano aggiornarci sulla prosecuzione dei loro interventi e delle loro esperienze. Questo lungo percorso ci ha portati, e sono lieto di parlarne oggi e di presentarlo anche oggi, alla seconda edizione di Spring Archeology, Spring Archeology 2022, organizzato, potete leggere, a Siena dal 27 al 29 ottobre. Di Spring a poco, ma il nome un po' è lo specchio di quello che il convegno rappresenta, cioè la rinascita, un po' il verde dell'archeologia in Italia e si spera anche all'estero. Abbiamo un altro obiettivo, oltre sempre la rete fra i singoli autori. L'obiettivo di quest'anno è quello di cercare di costruire una rete di una comunità fra i diversi convegni, seminari e conferenze organizzati in Italia e all'estero, così da rendere ancora più di libero accesso la conoscenza ai prodotti presentati e un po' anche fornire uno zoccolo duro, una base su cui i giovani o delle nuove esperienze possono appoggiarsi, possono un po' chiedere aiuto, dei consigli per sviluppare dei nuovi progetti. Un'ultima nota, anche per questa seconda edizione è prevista una tavola rotonda. Sia nella prima che nella seconda edizione abbiamo pensato di accogliere un po' le esigenze dei partecipanti, mentre nella prima edizione si è parlato dello stato di salute in generale dell'archeologia in Italia. Quest'anno, visti anche i vari problemi del mondo professionale che ci sono stati appunto negli ultimi anni, e gli sviluppi circa il riconoscimento della nostra professione, il tema cardine sarà il ruolo dell'archeologo nel mondo professionale, e sarà un dibattito che vedrà contrapporsi e confrontarsi in realtà il mondo del libero professionismo, il mondo dell'università e della ricerca, una forte componente studentesca e tutte le associazioni di rappresentanza, un po' per creare un dibattito dinamico e tirare anche ancora una volta le fila di questa seconda edizione. Quindi io vi invito, sono stato molto breve perché appunto era più una presentazione di quello che abbiamo fatto e che faremo. Vi ringrazio per l'attenzione. Per qualsiasi informazione io mi scuso, ma non riuscirò ad essere presente durante la discussione finale perché devo correre anch'io in cantiere, così come i miei colleghi, ma per qualsiasi informazione ci trovate sia sul gruppo Telegram di ArcheoFOSS e i nostri contatti sono sia sul sito di Spring Archeology che su quello di ArcheoFOSS, e vi ringrazio nuovamente.
Marco Montanari, crossover, digital public history, digital archaeology, virtual role-playing games.
Good morning. It's very soon. Slideshow. Okay, this topic will be slightly different, meaning we will look at usage of open access data and in a slightly different way. Specifically, where do I come from and why am I talking about this? I come from the project Open History Map. We work on open access data and publicly available data sets from several sources, trying to harmonize and connect them to make a usable map of the past. I'm a software developer and I am the president of Open History Map, and since a few months ago also of Fantasy Maps that uses the same technology for fantasy worlds and role-playing platforms. So what does it mean to have that platform for one and for the others? The first, the image on the top is Open History Map. The image on the bottom is Toril, which is the world of Dungeons and Dragons settings. And we cover a lot of information also on very local data. Meaning, for example, this is the city of Bologna in 1840, 1850. Based on real ancient maps, and this is the Rock of Brawl, also a setting for role-play games. With digital, with the Stranger Things and the COVID pandemic, the world of role-play games has evolved a lot, and there is a straight connection with public history, meaning games can teach us things. These are two famous projects. The campaign for North Africa is an extreme example, but Repubblica Ribelle is a project made in Modena to teach players how a small city in the mountains behind Modena was an important center point for the evolution of the resistance to fascism. And all of them are board games that can be played to tell us a story, to tell us how it felt in that specific moment in time and how decisions were made in that specific moment in time. And because this is one way to do public history. So digital world has also looked at public history in several ways: medieval kingdoms, the various Rome total wars, and whatever total war, adding information around the usage of generally a general overview of a setting that could be important. So let's look at something completely different. With pandemic, we said role-play games have evolved into something that was more and more common, and the settings have grown and become more and more usable. But for example, this is one of the settings of set in ancient Rome. This is in a virtual ancient Greek world, Greekish world. This is and the concept of grand mechanism is also in the 15th century. Is it's called clockpunk role-playing game in the world of Da Vinci. Brancalonia. There are so many settings that can be used if the data is available, because this is all information that comes from reconstructions, vague reconstructions, or in case of historical settings, it's just what in the role-play gaming world is called the theater of the mind, and a simple battle map to give you the feeling of what is going on. but you don't ever have the real feeling around you. And with the secondary project, we started working with Foundry to start looking at possibilities to tell stories with role-play games in the real world. Because, again, it's not an open source platform, sadly, but it has a great module platform that can be open. It's written in JavaScript, and it has a very growing community. And the result is fascinating, because we can have a city that is described with a lot of setting and lore defined in the source books, with the detail of a single player that can move around the city and interact with the world through the words of the master, so that the dungeon master or the game master in general can tell a story to the players and can give the players a way to interact with the world, a way to feel the world in a real sense. And for this reason, we are starting to develop. We started developing this tool for fantasy maps, and we are now prototyping it also for OpenStreetMap overview. So for modern day role-play games, to give the feeling or to enable people to at least have the feeling of a modern world interaction with settings that they might not ever be able to reach. With the growing costs of traveling, it will be probably one of the ways to interact with the world. And on the other hand, we started working on the prototypes with historical maps. And this part is still a prototype, still work in progress. But for example, a player could be playing in Bologna in 1840, so that he can see the city that is different than way different than the way it is now, and the way it is described now by our maps. So the concept of and this map is possible only because there is open data. In this case, it's open data given by the municipality of Bologna, because there is open access data that we rely on, for example, from a general point of view from the Pleiades project and the STOA project, and Creative Commons data with all of the information coming from basically abandoned projects in archive.org that were lost in those archives, but we try to again reharmonize them and put them together to create a real interconnection. Obviously, the world is still very empty. This is one of the only full structured cities that we have, but the work is in progress, and we're trying to merge the data in order to recreate a better view of the world. Thank you.
Adesso c'è la pausa, credo, Giulia. Sì, ok. Ci interrompiamo e ci vediamo più tardi. 15.
Very, it's just strange, but yeah, I think it will be better playing it, reading it. Okay, cool, but yeah. Especially for my book, okay. Yeah, that helps. My group is totally on the. That's so nice. Yeah. Because I find that there was one player that is totally role playing. If it's a whole team that does that, it's perfect. It's fun. The whole team is okay. So there's not emotional connection. The whole persona kind of complicated to mix the two roles. Ho provato un attimo a vedere dall'altro punto di vista. Ma tu lavori? No, sono un libero professionista, ma abbiamo fondato con Archeology questa associazione.
Perché non sono io il tutor, ma c'è un ragazzo che fa il dottorato giù a Catania di archeologia, che è proprio games per far conoscere. Quindi lui ha questa mappa di Catania, anche lui c'ha una mappa di Catania, e c'è questo game visto, per cui c'ha l'interfaccia digitale e contemporaneamente c'è il sito di bello, di cartone, quelli quadri, vedi il qualcosa di questo. Allora vi dico di scrivere, assolutamente qualche stella. Lui si chiama Carmelo. La prima volta che ti volevo dire a proposito di Colombia, tu sei in Cineca, poi ha fatto il modello 3D e ha fatto non era un gioco, però era una specie di filmare, quando un personaggio
con Apple Plus, esatto. Avevamo usato i modelli 3D perché il comune ha pubblicato tutto il pacchetto dei modelli come open data e abbiamo usato i modelli per fare andando a fare tutta una serie di correzioni e rimodellazioni che sono molto generiche perché riguardano
la figura che l'avevo fatto film,
sì, esatto,
ti interessava il
dettaglio. Però abbiamo fatto tutto un lavoro di riorganizzazione dei dati che abbiamo pubblicato su GitHub di tutti i modelli che loro hanno creato per fare un'ambientazione, per dare un ambiente virtuale su piazza di Porta Lavignana nel 1116, quando era ancora in costruzione una delle due torri e l'altra era già costruita, solo per far vedere com'era il mondo in quel momento. Era stato interessante.
La cosa che mi devo presentare, cioè, tu mi hai parlato di mappe, immagino che poi forse un po' più ampia. Come ti è proprio il sviluppo, cioè tu hai preso il fatto, no?
Certo.
Ma perché non andare verso
allora, perché Godot è implicato tutta la piattaforma. Foundation è una piattaforma già pronta, perché è una comunità che viene organizzata e su quello si può andare a sfruttare, cioè ci dava il vantaggio di poter dire ok, questa è la modifica per fare la poi è chiaro, sono d'accordo.
Non vuole ripetare la cosa.
Esatto, non vuole ripetare, sì, esatto. Da ingegnere da un certo punto di vista. C'è che poi. Sì. No,
sono informatico, però non sono archeologo, ci possiamo permettere di essere un po'.
No, assolutamente, no, ma intendo l'associazione, io e tre amici archeologi, con loro dicevano sì, perché sarebbe dicevano sarebbe bellissimo per fare una cosa che non si può fare, non può essere facciamo cercare di aprire. Ok, allora io mi fotografo il tuo contatto, te lo mando perché ti scriverà. Perfetto. Poi adesso credo dovevo, perché siccome bisogna fare scienza, non bisogna fare le bollette. Quello che si abbia un livello di insegnamento sulla che parte a Monza, quindi adesso non siamo non lo vedo da un po', però so che faceva questo lavoro, io non so il suo tutto, però mi ha aiutato per alcuni progetti. Ti metto in contatto. Perfetto. Grazie mille. Posso commentare Marco? Bellissima presentazione, perfetto. Ci siamo trovati come mettere a casa. Infatti l'ho fatto anche un po' per stanare gli appassionati. Esatto. Perfetto. Allora posso abbiamo un canale di cui facciamo comunicazione tradizionale, anche qualcosa legato al gruppo videoludico e gruppo tecnologico. Certo, abbiamo presentato un po' di giochi solo legati ai contesti storici, siamo stati bravi ad avere l'accesso su quello dell'ultimo invece. E finale di dire una sera Accademia di pubblicare Accademia di quando ho visto Corinth ho fatto 2 parti di dispari. Sì, ma quella dà tanta soddisfazione. No, poi ho fatto Torin, ho fatto Spelljammer, bellissimo, qui hanno fatto una porcata di guida, no, lasciamo stare. Adesso sto finendo Crino, dove tra l'altro ho visto che la comunista mi ha fatto dentro, tutto quello che avevamo indietro sulla timeline, di Crino, prima della creazione del buco, dopo il buco. E sì, e poi adesso sto facendo anche una porcheria, estremo, però cercare di capire come farla bene. Ovvero, usano un po' i canvas per generare il suono, ma se due gruppi giocano nello stesso ambito, se due parti giocano sulla stessa pezzo di mappa, ad un certo punto loro possono interagire gli uni con gli altri. Quindi io lancio una palla di fuoco contro un palazzo, il palazzo di crolla. L'effetto è che io cambio la mancia sotto, l'altro team viene aggiornato in secondo automaticamente tutti quelli che stanno guardando e vede il palazzo crollato. Quindi puoi generare un'interazione tra parti separati e questo genera un ovviamente di fondo, perché o lo fai sandbox puro oppure diventa devi gestirlo con del concetto di tempo. Siamo altri galassie di discussione perché per gestire il tempo la passione per informarci. Sì. No, ero certo. E lì ti rendi conto di quanto molto spesso anche non tanto le carte fanno l'utilizzo che ne fai, soprattutto su quelle che non hanno scala, sono sicuramente esatto. Si ha veramente quando spesso si scala per me era Barovia. La città di Barovia ha una proporzione, la città di Vallaki, questa strada ha una proporzione. Se tu li guardi, se tu li vedi
Le slide sono arrivate.
Ah sì, ok.
Paracciani rossi. Me l'hanno mandato ieri sera, forse? Non ho risposto, però le ho ricevute, perché ho visto sul telefono questa mattina e le ho scaricate, ma effettivamente chiedo scusa che non ho dato feedback. Ok. Ok. Regia, ci siamo, tra poco possiamo cominciare. Sì. Ok. Perfetto. In presenza uno e poi sono... Oh no. Paracciani è qua.
C'è Marco Montanari di nuovo,
Ok.
il nostro autore di...
Paracciani c'è?
Paracciani e Nicolò si
Esatto. Loro sono online.
Loro sono online.
Tagliore.
Questo
Ok. Allora. Facciamo così, esatto. Possiamo cominciare a questo punto. Io mi... Sì, sì, ma mo... Chi sei qua? Allora loro fanno... Fai tu condivisione tutto, fai tu la condivisione. Sì. Allora se voi fate... Sì.
Riprendiamo con Marco Montanari, Leon Silos e Luca di Static Publishing.
Again, good morning, everyone. Good morning, everyone. Yesterday we discussed a lot about interoperability, and for this reason, I think this is a bit relevant because we had a look with me and a colleague from University of Bologna. We had a look at static publishing. What does it mean to do a static publishing? It's not a new idea. It's something that came from back in the day when the internet was still young and simple. But it was used a lot by Google for Blogspot and Blogger. And it is a discussion going on in the digital humanities since 2015. But the main feature of static publishing is to publish complex content as a static website on a static code-driven provider, basically, nowadays. This means that we're using GitLab pages, GitHub pages, Netlify, and all static content providers to display the data and the content from our archives. Does it help integrate it? Help per se? No, it doesn't help integrate it. But it can be wrapped around static content files, which means that with a simple configuration, we can work around the structures of data we already have. Grazie. And it's a way to give context to CSV files, JSON files, and it is basically the simplest of the APIs, the download. You download a file, which is the simplest API. What are cases of static publishing? There are not many situations in which it is applied, but the situations are quite interesting. This is the collection builder. It's a beautiful application that tries to give the functionalities of Omeka, but completely offline, completely static, and completely managed through GitHub pages. Nope. actually wanted to share the link. Oopsie daisy. Fascinating. Because it's okay. Let me show you very fast. The collection builder is a complete open source platform per se, but it can be used through the GitHub Pages version. Exactly. And basically it's a serverless Omeka, and the development of the platform can be done directly through a template that can be used to recreate a whole archive, where the only things that the users and the developers can have to touch, have to interact with, is the data folder, where they have all the configurations and all the metadata and the content of their publishing. And this means that we can easily transform a complex problem that is the management of a whole server and a lot of DevOps operations, server to be kept up, server to be updated, server to be managed in some ways, can be delegated to GitHub or GitLab or Netlify. But this is not the only case. This is just an example, but for a read-only API, there are plugins for Hugo, which is another platform for static publishing, that enable the users to and the developers to create a RESTful read-only API. And this means that the same data that we publish and we have as a CSV file, we can filter, we can create a whole archive around that that data. We can have also static, completely static customized projects that rely on this. This is, for example, enslaved.org, a beautiful archive on a terrible topic based on the records of peoples in the historical slave trade. And this archive is completely made with static publishing. Complete the database is a set of CSV files, and the search and the menus and all the infrastructure around it is completely static. This means this is also also a beautiful example of static publishing because of the level of detail around it. But the main concept is that static publishing is not static sites in the old HTML sense of the word. This is another static example. Sadly, as Open History Map, we have our small solution. Sadly, the provider for the background images was a bit complicated to manage in the last few days. But the idea behind GeoContext is exactly to be able to describe a set of GeoJSON files and of CSV files, to transform them into navigatable maps and explorable maps, where we have the possibility to get the details of every single element in the map. This is a map. You have to feel the structure of the world in this case, because the gray background doesn't help. But this is a map of theaters, amphitheaters, and circuses in ancient Rome and ancient Greece, and they can be navigated and explored completely statically, because all of the configuration happens in JSON files, static text files, and CSV files. So you never touch the code, and the infrastructure is made completely in Angular. So it is a static element. We just go and change the files in the assets folder, and the structure is completely there. Why is it good? Why is it bad? The good parts are it's low cost, no cost, which is the best cost. Easily maintainable after a not so easy learning curve, because the first times might be updating the GitHub page might be a bit tricky, might require a bit of attention, but in general, it's easily maintainable. All is in the configuration, which is good, and as you see, it is also bad. The provider offers almost unlimited bandwidth, so it's not bad. Does not require servers, which brings us back to the low cost in general, and it is intrinsically open because the data is there, is in the same folder as the rest of the content. So everything is available to the end users. The bad parts, all is configuration, which means that the rules are set by who creates the tool, and that's it. You have to, if you want to go and change that, there is a bit to, quite a bit to transform. It breaks the bad part is that it breaks the classic consultancy and tender model, which means that if I have a project to deliver and I have to keep the prices low, I will no longer have the possibility to say, but you pay me this and that for the server. And this breaks a bit a long-running tender-based model, because you don't have a database to maintain, you don't have a server to justify costs for the administration or for the organization who requires this tool. It requires a change in the management process, because the data, there is no CMS, there is no WordPress page where you go and drop down and change the configuration graphically, because the configuration is text. It's text files that have to be changed. And exactly, there's no CMS, but it's a raw structure. And it's a good part. It's bad, but it's also, as a developer, good. So what what is the outlook for this kind of operation? We need use cases, because static custom applications are nice, but they are not reusable by design. And at the same time, what can we do with static deployments around what we already have? We could start using the backups. We discussed a lot yesterday about backup CSV files, using the CSV files. Why don't we make them usable and themselves the product? So we transform a side product into something that can be used online and can be explored and can be statically managed. Interactive exports, interactive preview pages. We can really use and write around these the elements we create as side effects of what we do through potentially simple infrastructures and simple elements. So the result of this analysis that we made with Lorenzo is that there is a lot of space to grow in with these tools. There are several. Jekyll, Hugo are the two most used, but there are several others evolving and coming up every day. But around these tools, there is a lot of space to explore, to analyze, and to look at specific needs that can go in a very specific direction. And that's it. Thank you very much. Grazie.
Okay, now Nicolò Paraciani and Irene Rossi, an open image atlas for the journal Archeologia Calcolatori.
Thank you, Alessandro. The first part of the presentation should be given by our colleague Irene Rossi, who's attending online. I'm not sure if she's already connected.
Yes, can you hear me?
Yeah.
Okay. Okay. Good morning to everyone, and thanks to the organizers of the conference and of this wonderful session. And apologies for being online presenting, but then I leave the floor to Nicola for the second part of this presentation. So as the first two papers of this session have already recalled, In the last years, open science and best practices policies have been increasingly promoted to extend public availability of publications and research data according to FAIR principles. The adoption of the so-called Diamond Open Access Publishing model has been especially encouraged in that it entails provision of scientific content entirely free of charge, both for readers and authors. Of course, such virtuosity is not without big efforts and difficulties. So from June 2020 to February 2021, a large-scale survey on diamond journals was carried out under the impulse of Coalition S, and one of the goals was precisely to analyze the strengths and weaknesses of the current landscape of this publishing model. And among its various interesting results, the survey highlighted that open access diamond journals that are independent from publishing platforms have to face on their own important issues related to technical obsolescence and continuously evolving best practices in scientific publishing. On the other hand, their autonomy grants them the flexibility and freedom to experiment so that they appear to adapt to change more rapidly and even to promote it. The case study analyzed in this presentation concerning the open access diamond journal Archeology Calcolatori fits well with this picture. This paper discusses the latest implementations in terms of both human fruition and machine consumption of the journal's contents with a focus on non-textual resources. So Archeology Calcolatori adopted the open access diamond publishing model at an early stage, when in 2005 it started publishing online the full text PDFs of its articles. The journal was also registered as an Open Archives Initiative data provider and has been exposing its metadata in a dedicated OAI PMH repository. This has allowed over time the provision of literature contents to various aggregating initiatives, such as Cultura Italia and Europeana. And lastly, in 2020, Archeologia Calcolatori landed on OpenAir, which is the open access infrastructure for research in Europe, and was integrated within its digital humanities and cultural heritage community. In order to be aggregated by this infrastructure, metadata exposed in Archeologia Calcolatori repository were made compliant with the OpenAir guidelines for literature repository and of its version 3 through a mapping of the database fields to specific OAIDC elements and respective vocabularies required by OpenAir. Soon afterwards, given the flexibility of a self-managed repository, the OpenAir staff suggested that the editorial board considered an upgrade to the latest guidelines, which in the meantime had become operational. This entailed the use of two richer metadata formats than OAI-DC, namely OAI DataSite and OAI OpenAir. The main advantage is that they multiply the possibilities of automated interconnections between datasets of different resource types, besides the strictly textual resources. So this new challenge seemed extremely fascinating to us, since at that moment we were precisely working at the valorization of other contents of the journal than the textual ones, and namely the visual resources. This interest in visual resources stemmed from the quite obvious consideration that visual contents, be they still images or 3D models described in the articles, are fundamental scientific complements for the understanding of texts, especially in the domain of IT applications to archaeology and cultural heritage. But how to facilitate the web creation of such sources, and even more important, how to enhance their accessibility and their use in line with FAIR principles. So our assumption was that visual objects should not be considered just as supplementary materials embedded or attached to a text, but as independent resources in their own right. And as such, they should be provided with descriptive metadata in order to be identified and used, and at the same time, they have to preserve the indissoluble relation with the literature resources they belong to. So to implement these new requirements, the existing model of Archeologia Calcolatori database was enriched with new entities for images and 3D models, provided with relevant descriptive attributes. These new entities have relations with the article and author entities, but also interrelations among themselves. The web page of Archeology Calcolatori website that you see on the right, presenting the metadata of individual articles drawn from the database, was adapted to include information on related images and 3D models. New sections named related figures and related 3D models were added in the page, where the thumbnails of all visual resources are displayed. The thumbnails are linked to the corresponding web page presenting each resource. This page displays descriptive metadata, links to any 3D models or vice versa, any related images, and a preview. Images can be downloaded in full resolution. And for the integration of 3D models, a tool was required that could provide fully annotated and linked metadata in addition to web review and downloads, possibly with simple embedding and interactive features, and with a minimal impact in terms of changes to the underlying source code. And for this, I leave the floor to Nicola.
Yes, thank you, Rene. And now we will show us a very short preview, a very short demo how we integrated the Atom 3D viewer and web framework, which is developed by our colleague Bruno Fanini within CNR. How this is embedded within the journal's web pages showing metadata of 3D models attached to articles. So it's an interactive viewer. It's also a web framework, and it provides a number of tools. In this example, we see measurement directly on the 3D model and zooming, etc., changing lighting. And maybe what makes yes, we also provide metadata in addition to visualizing resources on the website. There's also a dedicated archive on the OAI PMH repository of the journal with a set for images and a set for 3D models that are described by the datasite format, which is standardized by the guidelines for data archives provided by OpenAir. And so in the data archive, we keep the relation with both the article and the visual resources are related between themselves. So in this case, the image is related to its to the model it represents, and vice versa. And so perhaps the distinguishing feature of this presentation provided by the journal is the fact that both metadata and media previews and downloads are managed within the same user context and interface. This work began in 2021 when we started asking authors for information in order for us to populate the database with the needed information, and as well as providing 3D models with the respective metadata. But the journal has been going on since the 1990s. Early in 1990 it was, so there's a 30-year history of the journal, which would be very difficult to contact authors to retrieve this information we need for the website. So the editorial board decided to develop a separate dedicated tool to display this extensive archive, and it works as an image atlas, and it's basically a web archive that both collects and presents about 4,000 images, which span over 30 years of journal publications as well as supplement volumes. And the archive, the atlas uses the same database as the journal's website, although it can also work as a separate standalone application as long as it has access to its database table. And it can be browsed by publication type, so journal or supplements, by volume number, by individual articles or by subject using the same classification system as the journal. And there will also be a search feature based on the metadata of the images and possibly a tag system. In terms of technologies being used, the Atlas is a quite straightforward or standard web application in that the backend is written in PHP since originally the website was developed in PHP. So since we are maintaining the same environment, we also chose PHP, although we're trying to update it to the latest 8.1 version. And that's essentially a custom framework that handles HTTP requests and database interactions. And the database is implemented in MariaDB, an open source replacement for MySQL. And the front end is written in mostly in pure JavaScript ES6 modules. And there's not many dependencies except a few CSS and JavaScript libraries to ensure responsive design, a slideshow, as we'll see later, etc. And the HTML output that is generated by the front end, it's mostly generated by the front end, and it leverages the JSON API that is provided by the database, by the backend interacting with the database. So the same API that already provides data to the front end could be reused by adding features and documentation for interoperability as possibly a JSON REST API to provide this data publicly. And so this is a very short video demonstration of the first prototype of the application, which is still in quite early development stages. And so yeah, this is an example for a volume, in this case, volume 29. The articles from the volumes are presented in an image gallery. The images are selected randomly from the sect of each article. And by hovering with the mouse on the caption, it gives the full title of the article. And then simply by clicking on any article, the individual page opens with all the figures from that article with related captions. And there's this slideshow is based on a library called open source library called Spotlight.js, which is quite lightweight, but also provides a number of features like zooming or going full screen, etc. And we will also annotate these images with their corresponding metadata and relational links with the articles. So this was very preliminary. In terms of future developments, as we said earlier, we will certainly publish the REST API with the JSON data and appropriate documentation to provide the JSON data of all the images from the archive. And we'll also publish the source code on a hosting service like GitHub or GitLab. And we will try to implement the metadata to make them richer, to include, for example, more subjects and geographic coverage, etc., to provide a more extensive search feature and annotation. And so thank you for your attention.
Grazie Nicolò, grazie Irene per averci mostrato quest'altro strumento della rivista per rendere sempre più accessibili i suoi contenuti. E proseguiamo con un'altra collega del CNR online. Francesca Buscemi, Marianna Figuera, Giovanni Gallo, Angelica Loduca, Andrea Marchetti, an open source and collaborative framework for sharing structured archaeological 3D data.
Morning. I share the display. Can you see the presentation? Can you hear me?
Not yet. The presentation. The presentation is we don't see it yet.
Now I have to share the screen. Sorry.
We can see you and you can hear you, but not the presentation. Okay. Okay. So all perfect now. Thank you.
This paper presents the work project, a CNR ISPC project, aimed to apply quantitative analysis methods and machine learning to ancient architecture and to create a dedicated research infrastructure based on an open source technology according to principles of open science. An international and multidisciplinary research group met the challenge to create a participatory process of creation, classification, and querying of 3D data collections. During the project, a training dataset has been created consisting of over 3,000 digital models of stones belonging to 12 walls dating from the late Minoan 3rd C to the geometric period from 4 archaeological sites in Crete, Festos, Agia Triada, Sissi, and Aulokos. The idea of the project started from the activity of the Italian archaeological mission at Festos, directed by the University of Catania and supported from the CNR ISPC in charge of the topography and survey. In particular, the excavation campaigns since 2016 until today have been carried out in some areas of the Festos Palace characterized by architectural remains of the early Greek period. Almost unpublished, the architecture of this phase presents a particular complexity due to the strict stratigraphical relationship of the early Greek walls with the previous ones, and to the articulation of the structures where foundation of the Minoan phase, foundation of geometric period, and elevation are sometimes overlapping and had to be recognized and correctly interpreted. Finally, the reconstructive restorations of the 30s of the 19th century make it often difficult to distinguish the original section of the walls. A further difficulty is the lack of studies and even of standard terminology for protohistoric architecture in Crete, so that a human network and technical tools allowing a participatory reflection on the matter was strongly needed. Such a scenario suggested the possibility to test the potential of artificial intelligence in the interpretation of ancient architecture, and in a particularly difficult case, such as the poorly predictive prehistoric architecture. Starting from the realization of 3D photogrammetric, scaled, and georeferenced models of the walls, we set up the above-mentioned training dataset of stones. They have been archived in a virtual machine purposely conceived for the project by the computer scientist of the CNR ISPC, Niccolò Paraciani, and usable for all the partners through login credentials. Our purpose was that to query the 3D digital data and to extract numeric features significant for the archaeologists in order to identify building practices, working and setting up of the stones on a statistical base, evaluate continuity change in practices due to habitus, tradition, groups, identity, chronology, contribute to the definition of an intra-site related chronology of the walls, identify restoration patterns. The processing of the 3D digital models of the walls has been performed by Blender, version 3.2. The choice of Blender was based also on its completeness in supporting visualization, editing, and information extraction from 3D meshes. Furthermore, the rich Python API, BPY libraries, allows the creation of specific tools that are easy to develop and integrate within the Blender system. Each unit wall has been manually segmented and classified by the archaeologist to obtain a collection of 3D models of the wall face stones. The wall units have been partitioned into vertex groups representing the single stones. These last were organized in a hierarchic tree of objects according a logical model and a vocabulary developed during the parallel work on the database, which we'll talk about later. Therefore, a semantic category has been assigned to each vertex group. The recurrence of stone types could be visualized in a pie chart. In a further phase of the work, each vertex group has been exported from Blender into separate files in a wavefront object format. The collection of all the files has been stored in an organized folder system to be addressed and retrieved by a relational database for further visualization, statistical computation, geometry processing, and machine learning performed by Giovanni Gallo of the University of Catania. Within the whole project, the collection of digitized stones is being used for two general purposes: smart browsing and visual exploration, as well as machine learning analysis. As for the data exploration, a user will be able to query an online database which provides the answer in a coded message. This last, in turn, can be read within Blender via a suitable script and visualized in 3D. Proof of concepts of this workflow for some elementary queries has been already achieved with a purposely elaborated Blender add-on. A plethora of quantitative data has been extracted from the 3D models using public Python geometry processing libraries, as, for example, oriented bounding boxes of the stones, useful to know the dimension and length of the stones in the wall face, direction and variance of the normals to the triangles of the meshes, useful to analyze the working degree, or some proximity data between the stones to define their position within the wall and the structural use of each kind of stone. These quantitative data are an important complement to the raw 3D data because they provide a base to try machine learning approaches. In particular, they are useful such to train automatic classifiers that may assist the expert in classification and interpretation of the wall structures. Some preliminary good results have been obtained to automatically discriminate between rubble stones, that is, unworked stones used as building materials, versus wedges, stones saturating interstices between bigger stones, and to assess the most relevant feature that characterized these classes. In particular, using the random forest approach, an accuracy of 83% for this classification task has been achieved. The database is the core of the participatory and open process of the project, as well as to query the data. The first aspect that has been stressed for the management of the 3D data was a correct conceptualization and semantic classification elaborated by Marianna Figuera of the University of Catania. Because of the lack of databases specifically addressed to ancient architectural data, the SIDOC CRM and its extension CRM-BA devoted to archaeological monuments were the main reference. Its current version proposes 5 classes and 8 properties for the specific buildings archaeology model, linked to other SIDOC CRM classes and properties referred to the excavation model. The Art and Architecture Thesaurus of the Getty Institute was the reference vocabulary used to normalize the terminology. Starting from these requirements, a system has been created able to manage and query all the information in order to apply a deep classification of stones and masonries. The entities wall-facing stones and masonries are the fulcrum of the entity relationship diagram here in gray. Linked to them, there are many other entities which is possible to gather in 4 groups: localization entities in light blue, chronology entity in red, typology or characteristic entities in violet, documentation entities in yellow. After the ER diagram, a logical model has been developed which describes in detail all the entities, their attributes and relationships. The logical model was developed considering, first of all, the 3D data managed into the wall-facing stones table. This last includes all the quantitative data exportable from Blender in CSV format and descriptive information relating to the wall-facing stones. The masonries table collects all the descriptive information relating to each single wall, including its archaeological interpretation. In the table masonry types, the typology identified during our work on the vocabulary are listed. The table stone types includes the stone definition essentially according the parameters of the working degree and the size. On the base of this logical model, the CNR IIT, Andrea Marchetti and Angelica Loduca constructed the database. In order to facilitate the population of the database by the users, a web application was implemented based on Django, an open source framework. It also manages the automatic import of already available data, that is of the CSV files generated by Blender, and containing the features extracted from the 3D models of the stones. This way, as already said, the project proposes a dedicated research infrastructure based on an open source technology, allowing to disseminate the results of archaeological research in an innovative way and over the web. One of the main challenges was the choice of the database type for the data storage, which determines two fundamental elements: the ease of data management, such as the insertion and modification of data, the speed in executing the queries. Both aspects must ensure that access to data is open and in compliance with open access policies. At the beginning of the project, an evaluation of the most fitting kind of database in relation to our purposes was carried out. A relational database has been chosen because our data is structured and organized with a well-defined schema. A SQL language has been used. The infrastructure developed by the project is organized into the following parts: customization of the database schema according to the needs of archaeologists and the logical model, a web interface for the manual insertion of new entities in the database, respecting the defined schema with the related constraints, a command line interface for the automatic import of data already available in the indicated format. This image shows the architecture of the proposed framework, where Django is the core component and manages direct access to the database. Archaeologists can add new entities either manually directly in Django through the data entry module or automatically through the Blender software, CSV files. The Django framework also provides a user interface allowing web users to access the content of the database. Web users could include scholars, researchers, other archaeologists, and even common users who want to access data. Different roles could be created to manage access to the resources. Currently, role management has not been implemented in the platform, but an authentication mechanism could be envisaged. From an open science perspective, at least basic access to resources should be guaranteed to all users, including non-registered ones. This basic access could involve consulting at least the name and description of each entity. Then, based on the role of the user, different details could be provided for each entity contained in the database. This is an example of the data entry module for the manual insertion of a new wall-facing element. For each entity, the list of the attributes specified in the database schema is shown, thus making it simple to add new values. Depending on the attribute type, the data entry module will show a different box, such as a text box, a drop-down menu, or a link to an external entity. The interface, in particular, is conceived to easily manage relations among entities, that way encouraging an archaeological reflection on numerical features of building materials, patterns, and architectonical practices that the use of artificial intelligence can consistently improve. Thank you.
And now Marco Moderato, Roberto Taglioretti, Alessandra Mazzucchi e Vasco La Salvia. Mapod 4D, a multi-metaverse for archaeology, anthropology, and cultural heritage. Sì. Ho messo tutti e due.
No, lancio tutto qua direttamente così non ci sono. Condivido. Condivido lo schermo. Siamo ancora dietro le quinte, però forse ci... So, good morning, everybody. Here we are again, and we are presenting today our first preliminary work on Mapod 4D. So, in the last few years, the terms multiverse and metaverse had found a lot of internet interest all around the world, especially since also Facebook Meta is developing or should be developing their own metaverse. But in the field of cultural heritage and archaeology, this kind of tool has not been developed still, and it is in its early phase of studying. So what we are presenting now today is Mapod 4D, which can be defined as a multiverse of metaverses, so a container of containers, we might say, which is actually a virtual environment simulated through software, and in particular based on the Godot game engine, which can reproduce 3D and 2D and 3D worlds in a very detailed and articulated way. One of the main keys of our environment is the fact that metaverses can be linked to each other, can be linked to every kind of our activity. We are developing now ours based on the content, on the stratigraphical context of Casa Piccoli of Castelsepro, which we talked about it year earlier yesterday. But it also can be applied as a framework to physical anthropology, and there are already some examples of that. We will give you all the context at the end of the presentation. Archaeology, history, and arts. All the information that are contained in this virtual environment are actually affected by reality itself, which means that they are affected by gravity, we will see in a bit, and by time. So in our metaverses, time and space are actually, let's say, mirroring the real time and space. In a way different from other kind of virtual realities,
Our is, of course, fully FLOSS, free, libre, and open source based. And one of the main keys of being FLOSS is that we can also program the interaction we have in this reality. And we'll see in a bit why it's very interesting. So as you know, in metaverses, there are avatars which moves around in space, and the choice for our avatar is a probe, and from which it comes the acronym of our environment. So multi-analysis probe drone. Why a probe drone? Because we intend the avatar as a sort of sensor to engage in the reality. So we can interact with the reality, and we can observe a reality like we are a sensor of a drone, a probe of a drone. Of course, the background, and if you want deeper technical info, we are available, of course, in the discussion and the rest of the day. It's fully, as I said, FLOSS, and it has a very strict timeline. Actually, the thing you will see today has been developed thanks to Roberto and his team in less than 2 months, since we met actually in June, and we have developed the first preliminary case for our environment in less than 2 months, starting from a core that was already working. So it was a very solid foundation, and we have a first timeline which comes until the end of 2023, which involves both the developing of the core of the project and also the dissemination of the project. As Roberto always underlines, disseminating means involving people and building a community, which is crucial to the development of this kind of activities. Again, what you will see in a bit, I'm going very fast to leave more space to the demo by Roberto, is really the tip of the iceberg. So we of course, in 2 months, we couldn't develop all the things, but we have planned the interaction of all the fields. So digital image elaboration, data repository, digital laboratories, and sensing of information, already encapsulated in the idea of the development of this environment. So without further ado, we can move to navigation.
This is a multiverse?
Yes, this is the main metaverse. So we already passed the main menu in which we choose the metaverse to see. And as you can see, there are planets, which are our worlds, we can say.
We are into the planet.
Exactly. We are already in a container, and we are seeing different containers.
Spherical area with a planet. This element is a real planet.
Possiamo entrare nel primo, direi.
This is a single planet that is like a single game, a single element, and we load everything to see.
So as we mentioned before, we are developing the environment in the Godot engine, which is a game engine, and so it is structured for gaming, and the metaverse is able to link and put together like they were different gaming worlds. So this is the first one. Unfortunately, the quality from streaming is not exceptional. Actually, it's in high definition on the local computer, and we are planning to move it on the server so we can interact via HTML. The first planet is the actual context of excavation, and you can see the room A, the first room we are excavating, and this is the main object inside. And Roberto now is moving through time, so he's moving in the space around the area, which is in a real dimension, and he's also moving through time. So the excavation is ongoing. The first thing of interest for us when we met Roberto actually was that he was recording the sounds. So actually we have the full record of the excavation, not only from a scientific point of view, we can say, but also from a human interactive point of view, which could be useful for making people understand where we are actually going into the excavation. Forse devo attivare il volume che era spento. No,
non sono io.
Okay, you have to trust that on the sound, the people on the room heard it. So actually, what you are seeing is different objects that are the different phases of the excavation. Every object is also linked to a object database, so there are data linked to the single object, and we are developing the interaction with the object itself. So it will be possible to measure things, to explode objects, to associate other objects as well to a single object. So we can call back, for example, 3D models of the artifacts we found in a context in excavation, and we can add the time factor to that. So we can differentiate the object we are calling back using time, for example. Here we are seeing the interaction between the physical 3D model of the excavation and the superposition, the overlapping of the magnetic anomalies recorded on the site. One of the things that struck us in the interaction with Roberto, that the core elements of Mapod were already planned to interact with other kinds of data. So we can link with APIs to our database, to our stratigraphic unit sheets, and actually you can have a real interactive 3D model of the excavation with the data linked. So we are going through towards a global documentation of the excavation, which links single objects, single elements, stratigraphic references, and so on. Ci vogliamo spostare sul... This is the portal to the second planet, to the second world. We are still inside a sphere, a planet, and we are actually inside a room. What you are seeing now is the data of the drone flights that took the photos of the excavation in real time. So you can actually evaluate how, for example, data were recorded. You are seeing the actual, in a 3D model, of course. It's not the real model of the drone, but that drone was recording the excavation. And if you look at the window, the images that the drone was recording are now shown linked to the coordinates of the drone moving through the excavation. So it is also useful to evaluate the documentation realized on the real excavation. And as you can see, the room is actually a container which is inside the planet. So again, gravity is working here. So if we were touching or moving an object, it would fall on the ground if there is no a plan or a solid object. And we can interact with other kinds of data. In this preliminary show, we have attached data directly on the walls of the room, but we can, in the interaction that we are programming, calling back directly from other objects. So for example, we can interact with an artifact and recall its artifact sheets, and maybe we can also interact with the object. So we were thinking about, for example, with the 3D scan of the objects, we can cut them in half to see their section and to compare, for example, pot shards by their section in a interactive 3D environment. So we can move to the next planet. This is the so-called shop. Actually, the structure of the planets was taken from another previous project in which it was required to have an exhibit room for a museum. And so you can see all the team that are already worked on the project. So we are building a community made of software engineers, archaeologists, anthropologists, law experts for policies and so on, all in a FLOSS environment. And this is also, of course, our sponsor and our acknowledgement. We already have made available the framework of the core of the MAPOD environment, which of course is built, as you have seen, on this FLOSS software, on the GitHub of our website. Just moving so they can see. You can find the showcase of the project already realized in the MAPOD environment on MAPOD, the mapod4d.it, which is our new website, and of course the GitHub with the framework, the technical documents, the policy, the policy and the manuals on the github.com/mapod.
From the website, you can download also some metaverse, museum metaverse and
anthropological metaverse.
Anthropological metaverse.
So, for example, we were looking at anthropological artifacts and how to scan it and to how can I say?
You can recite the bone in real time and see the figure,
the structure, the figure, and the details of the. So it's as we said, it's a very preliminary exhibition of our project and the tip of the iceberg. We are studying how to interact with machine learning, for example, to study wall, like we've seen in the previous presentation. And also, I forgot, MAPOD is already built for virtual reality and virtual visor, 3D augmented visor to interact. So visors, gloves, and so on. Maybe it's a dream, but we can say we may touch in remote our artifacts in a digital laboratory, and we can also publish not only from a scientific point of view, but also from a global point of view, our excavation. Thank you very much.
Now we would like to invite Paola Moscati just to close the panel before the discussion.
Good morning, everyone. I'm very pleased to be here today in presence in this new edition of the ArcheoFOSS conference. First of all, I would like to thank Paola Buzzi, director of the DigiLab, and Giulia Bogdani for the invitation to take part in this discussion. Since time is short, I would like to make only a few comments on some key elements recurring in today's presentations, which suggest some cutting-edge issues on open access electronic publications. When we started publishing Archeology, Calcolatori in open access in 2005, choosing what is now called the diamond model, we consider it an ethically evolutionary step. Today, after the publication of focused studies and conference proceedings, the journal is witnessing the evolution of the open access movement toward the open science paradigm. This means that data dissemination is not the only goal pursued, but it is accompanied by other emerging and pressing issues, as it is evident from the research project illustrated today. I noted, for example, the spread of new models of online scientific publishing and their sustainability, the problems of research evaluation through the deposit of preprints in open repositories, and the creation of community-driven systems for peer reviewing and for the unrestricted access to scientific data and published platforms. New scenarios for public history experiences, the metaverse revolution to build a virtual environment in which to explore archaeological data, and the improvement of the multimedia experience in browsing electronic publishing, the implementation of web applications to create a collaborative environment for archaeological information acquisition and exchange. In conclusion, there are many topics on which to start the discussion, and I ask if there are any questions. I don't know if they are online also. Any question?
If I may.
Yes, of course.
Well, I was very interested about the topic that was discussed by PCI in archaeology. So I would rather ask how to become a friend journal, because that's pretty interesting, and hopefully we'll be in touch in the next days. But it's most interesting to create some interest also in Italy towards this kind of movement, and also to gather some journals about archaeology, or also on methodology or other similar issues to get joined. So this was my first question, and in a second instance, about the talk about static publishing. It is most interesting because we have been experiencing here at Sapienza with PhD program in history, with younger students trying to publish their research in a different way, not only as journal articles or monographs or whatsoever, but also from a data point of view. So publication of data sets or data-driven research. And we've been using static site generators for this because this is very easy to use from one point of view, and it gives good literacy on data. So they work on the structure, and they don't care about how the visualization is built. So these kinds of tools, that static site generations and GitHub pages, Hugo and whatsoever, can be very useful for also for teaching, not only for scholars who want to publish their research, but also in the universities on other kinds of. This is something that can be a little bit investigated more also in the teaching in the university. So workshops or whatsoever are most welcome also in Sapienza. Started doing something, but it's a topic very interesting to us. So.
Maybe I can start to answer to your question. It's very simple for a journal to become PCI friendly. It is just it's just a matter of a survey online, and it asks a few questions, The thing is to discuss inside the journal editorial board first what kind of PCI friendly status you will choose, because some journals will state that every PCI archaeology recommended paper will be published as is because they consider that the review has already been done. But these are quite rare journals. Most journals state that they will give quick answer, and of course they have to check that the paper is in their scope, that the reviews were good, because of course, like for any journal, sometimes the reviews are quite short, or sometimes they won't agree with the editorial decisions, etc. So that's the matter of the editorial board of the journal. And of course, being PCI friendly doesn't mean that all the papers of the journal will go through PCI. It's just that you accept submission from PCI and you tell the authors what will be the consequences of a paper already being recommended by PCI.
Just a word on static publishing. I totally agree. It enhances the literacy. It enhances the literacy on data. It shifts the point toward at which you stop. Because, for example, as you said, with PHP, it's easy to go towards an application, but it requires also to understand some aspects of coding, which is something that is removed in static publishing. So again, it is a matter of data literacy. It removes something from coding literacy. So it's a trade-off that it's required to understand. But again, it's a matter of being aware of this trade-off and deciding where to put the baseline of what kind of literacy you're looking for. Thank you.
Thank you. Any other speakers?
If I may say something, maybe a bit rude about peer reviewing and publishing. I think we cannot disguise the main problem that we have, because we can keep on talking about open access and a friendly environment within the open access, but we still have a big problem, which is monopoly on the big publishing houses, which at the moment are owning the vast majority of the journals. And our environment, which is a community environment, is, let's say, non-competitive, whereas in front of us, we always finding the highly competitive world, which is based on something that we can frame as the introduction of the high-speed capitalism into science and culture. So either we face that and we start thinking really how to break the system, or we can would be considered forever as the trolls of the fairy of the fairy tales. So that's the main problem, I think, that we have to face, because one way or the other, at the end of the process, we would be confronting the monopolistic system of publishing. And this is what we are asked for our career, for succeeding in in international and national projects. And if I am comparing the quality of the articles that you can go through, the journals edited in the 60s, in the 70s, and until the very first half of the mid of the 80s, and what it is published now within this so-called peer reviewing system, well, I have to admit that there is no comparison possible. There is a lot of junk having been published within that system, which any editorial board of any of the existing journals in the 60s, in the 70s, and in the early 80s would have never accepted as to be published. So we still have a big problem here. And I'm fairly convinced that within the open access community, there is much more care and attention to the contents than to the title of the papers presented than in the outer world. So I'm sorry that I'm being so rough on that. But I think that this is something that we have to face one way or the other. Thank you very much.
If I may intervene here, that's exactly the point that the creators of the peer community and system wanted to tackle, because the thing here at the beginning, the thing was to recommend preprints. So it was to get out of the publishing system and out of journals, especially for the peer reviewing process of the journals, and having open peer review, so every reader can look at the different versions, the submitted versions, the version 1, version 2, etc. Every reader can read the reviews and the answers to reviews. And at the beginning, the thing was only to recommend preprints. But the problem is that the system is presently and currently based on for many careers, in many countries, etc. The fundings of the laboratories are based on the number of Q1 or Q2 papers, etc. So in the end, they made this PCI friendly journals and even their own diamond journal. But I know that for archaeology, for example, this diamond journal created by peer community is not very useful because we already have a lot of diamond journals. But in fact, they created this journal because of ecology and evolutionary biology PCIs, which don't have so many diamond journals in their field. And that's really a problem to rely because the presentation was quite short. I removed some slides, and one of the slides I usually present is exactly this oligopoly of the publishers, with 5 main publishers publishing more than 50% of papers in the world.
I say a very simple and banal thing. To resolve the problem of the monopoly of the editors, the only way, I think, is that the state and the Ministry of Research pay once and for all for the open access and the results. As I see, if I understand well, it happens in France, where there is a node, a state controlled and maybe sponsored by the state, which that's the very banal resolution, I think.
Can I ask a question How is it in Italy? Because there is an acceleration in France, like Gaël has said, and for journals in Italy, what is the situation? Archaeological calculatory is in advance, maybe, and the others.
The problem is that open access is not for free. This is a question, and Archeologia Calcolatori is an institutional journal, and if the CNR let us publish it, giving helping us to publish it, we will continue in this way. Otherwise, if there is no institutional support, it is impossible to publish for us in open access, because we are still using a publisher because it is a specialized publisher in archaeology, and because I think that homemade journals have not the same quality that something published by a real publisher. And if there is no institutional support, we will not come back, because we do it on the ethical point of view that the research results should be disseminated. So if you will not have, we will not for the future have support, we will not continue the publication of the journal. Because open access, or the model is the diamond model, or for us, it's easy to say that a journal is open access when authors should pay in advance for publish. CNR is highly the library of the CNR, the library Guglielmo Macconi of the CNR, is now working to help the diffusion of open access, and also I don't know how they say, some contracts, tipi di quei contratti, with some contracts, transformed in contracts with the publishers, because obviously CNR has not only an interest in the humanities, but also in the scientific sector, where this is, I think, a much more big problem than in the humanities.
If I can add something, I mean, the solution, we have kind of solution also in Italy and the European Union, because it's not the matter of financing the industry, because publishing is an industry, they have to make money, of course, and they cannot be paid by the state. I mean, Elsevier will never ask to the Italian state to be paid for, but the most important movement is that national funded projects in Italy and also European funded projects actually require you to publish only in open access. That is the way that you can change the market. So they are pushing the market towards open access. So major publishing houses are changing their publishing plans, and they are offering for money, of course. For money, of course, yes. But I mean, somebody has to pay. If you want to publish with De Gruyter, it's your choice. You can publish with anybody, but if you want that, of course, you have to pay for that. They're private institutions, so it's up to you. It's up to us to refuse major publisher. That can be done, for example. We don't have to rely, but most of the time it's us who want to publish with Elsevier, De Gruyter, or whatsoever. So from the funding point of view, things are changing. Actually, in Italy at least, you don't have any public funded project that can publish not in open access, let's say, or at least some kind of open access. So this is probably something that will revolutionize the market, at least in scientific publishing in the next years. So.
If I may, just a few words about this thing of publishing and diamond open access. We have the University of Pisa in our lab. We have a very, very small journal that is called Archeological Data, and that publish open access papers and also all the archaeological data as open data for free of charge, with a publisher if you want the paper copy. Otherwise, you have everything online. Unfortunately, this system is working only with our research funding, because neither our university nor the state give us money for publishing in this way. So our luck is that our paper is not so big to publish hundreds and hundreds of pages, and we can afford this system till now. Our university was thinking about giving to all to the university and to all the researcher of the university an open journal system a few years ago, but unfortunately we haven't it yet. So we are publishing with a publisher with our money, and we are waiting for an open journal system. Maybe another way could be this one: if university will give researcher the opportunity of having open journal system, and the university are able to create a journal in this way, we can try to break at least a little bit this monopoly or oligopoly that is the one that is in Europe, not only in Europe, for publishing our research.
Good morning. My name is Giovanni Gallo, and I'm a computer scientist. I'm not an archaeologist, so I beg your pardon if I be too naive, probably. But the problem of open publishing, it's science-wide. It's equal for all the fields, and the pathological things that you pointed out are seen in computer science as well, probably worse. I think a naive probably solution could be one that we experienced in the COVID crisis. During COVID, we needed immunization, and the European community forced the oligopoly of laboratories, saying, I will buy from you, but you have to give me a very low price. And probably that could be a solution from the institutions. I mean, if all the research ministry of Europe will join and face Elsevier and say, we will pay you a fair price if you publish all of our public research in a certain way, probably things will get a little bit better. It's a very naive solution, I believe. Of course, there are a lot of difficulties in the road, but I think as a scientist, we should start pushing our institution to go in that direction, to have a lot of a class action as ministries toward publishers, and that could help us in this direction. I'm sorry if it looks naive, but probably good things may start naive.
I perfectly agree with the last speeches and above all with Julian, what Julian just said. There is another topic I think on this matter, that is that the the review committee, the reviewers of the articles are we are as scholars. So I'm very happy to give my time and my effort for free to journals who have public access and are open access. I don't think it is so right, even from a legal point of view, to give for free my work to an enterprise, which is on every point of view a business enterprise. So I think it is a topic that has to be taken into account also by the authorities who work on that. And it is a topic that I think we should face in this sense. Thank you.
I couldn't tell better.
Thank you. So we'll take 10 minutes for a coffee break and then have to the last panel of this morning fastly. Thank you all. Thank you for the people connecting via internet. Goodbye.
Thank you.
Bye.
Hi, welcome. Good morning, everybody. I am Paolo Rosati, chair of this last section of the morning, and I have the pleasure to introduce very quickly, just because we have some delay causing of the previous so beautiful discussion. I have the pleasure to introduce the paper of my colleagues and friends, Florian Thierry, Allard Mers, and John Brady Kisling. In this panel, we will talk about from Wiki project to OpenStreetMap, collaborative approaches to open data creation, problems, case studies, territorial and cultural impact. So, Florian Thierry, researcher, software engineer, and data scientist of the Department of Scientific IT at the Romano-Germanic Central Museum of Mainz, Germany, working in the domain of semantic modeling, linked open data, and Wikidata. The Dr. Allard Mess, FSA, is an archaeologist and the head of the scientific IT department at the Romano-Germanic Central Museum of Mainz in Germany, dealing with the same topics. Dr. Bradley Kisling is a former ancient historian archaeologist from California, currently interested in Greek religion and Greek topography, and integrating data into Wikidata, especially in the Topos text project. Thank you so much. Are you online? So we can start to present your paper.
Also,
okay, sorry.
Yeah, if you can see my screen, it should be
yes, correct. I confirm.
Okay, so then I will start. Okay. Yeah. So myself, my boss Allard, and Brady will present today something about Wikidata, especially challenges in research community building and how to integrate theoretical data or Samian into the Wikidata community. And as you all know, community building creates a network. And this also applies to data. And in the end, we will have a huge knowledge graph. And you see here just an example of philosophers and somehow the semantic modeling behind it. And as you also hopefully know, nodes and edges can create an RDF-based semantic network, which is called linked open data, which follows just simple rules that you have two nodes connected with an edge, subject, predicate, and object. And there is a standard from the W3C, which is called RDF. And if we look at Plato as an example, it could be described in the FOF vocabulary, so the friend of a friend vocabulary. So, for instance, Plato is of a type of person, so for instance. And on the other side, we have Wikidata. If you don't know Wikidata, just a brief introduction. So Wikidata is a free and open knowledge base and data hub where everybody can add and edit data. And Wikidata is the central storage for structured data of all the Wikimedia projects, so Wikipedia, Wikimedia Commons, and so on. And the good thing, or sometimes bad thing, is that data in Wikidata is available under a free license or under public domain. This is 0. It's multilingual. It's accessible to humans and machines with GUI, API, Sparkle endpoints, whatever. It's exportable using standard formats like JSON, RDF, and XML, and it's interlinked to other open data sets into the linked open data cloud and other repositories in the internet. Just a short introduction into the Wikidata's data model. We have two main types. One of them are the items itself and the semantic modeling using some kind of statements. So all the items into Wikidata have identifiers, have labels, have descriptions, and an alias, hopefully. And the main thing is that everything is modeled as a statement. So you have a property, something that describes what you want to express. Then you have a value, you have a qualifier, and the main thing, you have a reference. So you have to say normally what is the source of this kind of information. And with all of these things, you can build up a huge knowledge graph where everybody can have access to and can edit. And if we have a look back to Plato, this here is a unique Wikidata URI and an identifier with Q859, which, can here see a picture which is also interlinked into Wikimedia Commons and a lot of other translations and so on, and data about the philosopher Plato. And the linked open data principle should be applied to domain-specific archaeological data as well. And here comes the Samian Research database into play, which is a treasure house for economic data on Roman trade, comprising more than 250,000 potter stamps. And over the 6 decades, a broad European community was built up, and and this community consists of research institutions, citizen scientists, and domain-specific scientists, which curate the Samian research dataset. And the data was then mapped to places, for instance, in the Pleiades gazetteer, and also to the ceramic typologies, Ceratite ontology. And it is accessible as linked open data via the LOD hub archaeology.link. And in 2020, Samian Research began a process of integrating its data with Wikidata through the creation of a set of Samianware Wikidata items. And so the question is, where can you find that kind of things? What is in Wikidata from the Samian Research database? You can just ask the Spark query service, and you can find here that Wikidata contains more than 3,000 Samianware discovery sites, which are an instance of a Samianware discovery site and is part of Samian Research, and also have a backlink to the LOD dataset in our own database. There are also more than 100 Samianware production centers, which are an instance of a Samianware production center, and also connected to the Samian Research database. And we also have a backlink. And there are also some kind of clusters of these production centers, which we call some kind of kiln regions. You can see here, which is also an instance of Samianware kiln region and part of Samian Research. Yes, but the approach of creating special purpose Wikidata items is an efficient way to map the huge geographic reach of our subject. It refers to many European archaeological sites and excavations which hitherto lack the Wikidata identifier. Like you can see here, this is a new site into Samian Research database, which has currently no Wikidata identifier. And this one-directional way, due to not directly declaring Wikidata entities in Samian Research, does currently not allow its sites to be merged automatically with existing Wikidata items for archaeological sites and excavations. And we will just show you that in a short example of Corinth, and I will give over to Brady Kiesling, who will talk about that, and I will click the slides. Thank you.
Well, thank you everyone for the invitation. Thank you, Florian.
My name is Brady Kiesling. My goal as a scholar living in Athens is to put historical and cultural information in people's hands, when, but especially where that information is relevant. It was first through Topos Text, a project I created with a gazetteer of ancient places and a library of ancient texts linked to the places and people they mention. But increasingly, my focus is on using Wikidata for that purpose. A current personal project, for example, is uploading modern Greek monuments, commemorative sculpture, war memorials, etc., directly into Wikidata with their artists, their subjects, and especially their coordinates, so you can find them and map them. Now, ideally, a Wikidata item will exist, and soon it will exist, for every archaeological site on the planet, with coordinates, with links to excavation data, with links to ancient sources, perhaps through Topos Text, and with practical information through links to official websites. Now, the Samianware project, which is an amazing scientific resource I commend to your attention, took a step in that direction by creating these special purpose Wikidata items to make its structured data more visible, more accessible. However, for the Greek sites I knew, I thought their items would be more useful if they were aligned to existing Wikidata items that overlap with their sites. Allard and Florian saw some logic to my suggestion, but help is needed because this alignment is delicate. Obviously, I'll start with Corinth because that's a site I excavated at in 1980. The modern city of Corinth on the left is not equal to the village of ancient Corinth on the right. Samianware had, in this case, done a fairly simple alignment that put it somewhat in the wrong place. Next slide. It's important to remember that the ancient city of Corinth, which is a polis in historical literature, is not semantically the same as the modern village of ancient Corinth. It's not the same as the archaeological site of ancient Corinth. It is not the same as the Corinth excavations, which is an organized activity by the American School of Classical Studies. And of course, it's also not the same as the modern city of Corinthos, which is on the coast a few kilometers away. Each of these separate Wikidata identities has a separate set of properties appropriate to its role. In addition, ancient Corinth, the archaeological site, has about 15 other Wikidata objects for specific monuments. And in some of those cases, those monuments are in themselves Samianware sites. Next slide. It's crucial to me that we have sites, have Wikidata items for excavations, because that's where you hang the scientific information. It's also crucial that we have sites because that's how you find things if you are a practical person going somewhere. The ancient place is necessary because that is the hook for most of the historical information derived from ancient sources. Then the modern place is fundamentally important as essentially the management for the archaeological site for the people who visit. Next, please. One thing that's quite clear is, from my experience, is Wikipedia likes to put everything in a single article, whereas Wikidata experts want a separate item for each semantically distinct thing. And we have a problem that occasionally the Wikidata items I create are merged with the modern village, and unmerging them is a nightmare. But good linked open data will keep those distinctions at the Wikidata level, if not necessarily at the Wikipedia level. Next. The problem with creating a separate entry for each site, for each excavation on a site, for the other things, it is labor intensive, it is rigorous, and often we have the problem that a given Wikidata item will not have enough properties to be very useful. And let me use an example of something I've been working on. I have a very bad habit of plundering the work of friendly archaeologists and turning it into Wikidata statements. One of the best projects I know of in the world has been by Dipolon.org in Athens to map every salvage excavation in Athens. Next slide, please. I have turned each of their 1,400 salvage excavations into a Wikidata item. In this case, combining the concept of excavation and archaeological site, because neither of them has enough properties to warrant it together. But the result is to make their work mappable and directly accessible through Wikidata. Next, please. The purpose of doing this, in my mind, is to then empower the public as well as scholars with apps that will read the Wikidata material around them and notify you discreetly what you are walking past, so you can follow up if you want to. But let's go back to Samian-ware. Pompeii is an excellent example of a standard Wikidata item now, where the ancient city, the modern archaeological site, and the excavation are combined in a single entry. It would be excellent to separate them, because there's a rich archaeological history, and there's a very detailed archaeological site, and then it's complicated. Should the Samian-ware discovery site, which Wikidata item, be linked to Pompeii as the site, to Pompeii as the excavation? I don't actually have an answer to that. Right now, we don't have to answer that, but someday we will. Next slide. So, I mean, my personal vote would be to link to, would be to mobilize archaeologists, the whole archaeological community. Every excavation should create a decent Wikidata item for itself, link to the crucial sources, and then look to Samian-ware as a place that should be, very likely the two items should be merged. Otherwise, they should be linked in some way that we should discover. But anyway, my plea is for the community of linked open data scholars to look in this direction. Thank you very much.
Thank you so much.
We just have 2 more minutes, if it's okay to conclude.
Yes, of course.
Wikidata community must be enlisted. And then, therefore, Wikidata properties and items, they suffice for almost a full range of Roman ceramics data. They reflect a diverse and active community of users, but also a very diverse implementations of data models, which makes it so complicated. Therefore, the knowledge exchange must be enabled, for instance, by bidirectional links using properties in Wikidata. And the solution to this can be the creation of an archaeological.link property, of this linked open data hub, allowing for multiple exact matches to be discussed with the Wikidata community. Because At the moment, there's only one option possible. However, in such a specialized domain, the question is whether these community-validated data entries can really safely generate new knowledge. And we consider Wikidata community projects in archaeology as an umbrella for community initiatives like Linked Open Semianware to address issues of sustainability and data consistency. At the end, we'd like to thank you for your attention, and I would like to point out that there is also a psychological aspect to this, that archaeologists themselves should really learn to let alone the data in the wild of the Wikidata world. The thing is that archaeologists tend to wanting to keep the data under their control, and it definitely isn't anymore. And I think we pointed out that there's a lot of work to be done, but it's the only way we can go. Thank you.
Thank you so much. Thank you for your interesting paper. And the discussion will be at the final part of the section, as in the others. And now it's my pleasure to invite here Roberta Manzolino, Mariflora Caruso, Paola Latorre from DigiLab ArcheoArte 3D Lab. They will talking about the enhancement of local museums through Wikipedia, the Medagnane project. Okay.
No? No, non c'era mai l'allenatore. Aspetta. No, però non c'è.
Cosa è successo?
Se faccio così, cioè solamente le slide, non c'è il testo.
Metti quell'altra.
Però si vede anche lì poi.
Non si vede online.
Almeno qui sì. I'm sorry, just a moment.
La modalità presentazione leggendo il testo.
Relatore, o il testo?
Però si vede online.
Ce l'ho nelle slide, perché pensavo ci fosse un relatore, non si può. Allora, magari faccio, no, faccio dopo. Vado a stampare il testo, facciamo il cambio. No.
Okay. I'm sorry, we have a change of program, just because we have the text directly on the PowerPoint. So Roberta will print her paper, and then we will present this paper. I will ask to Marco Montanari to take the floor. Thank you. You are essential.
No problem.
Grazie mille. Hello again. The idea of this talk was to look in general at the sorry, you're right. The screen sharing isn't on. Thank you. Thank you. Okay. I was saying The idea of this talk was to look at several tools or generally used tools for citizen-driven digital public history, or in general citizen science, because this we tried in several ways to involve people from the local communities to work on data, and it was a complicated story. Why do we want to go citizen driven? Because there are many volunteers that could simplify our work, that could work at low cost. You offer them something to eat or something to drink, and they do stuff. Because there are experts out there that we don't know of, and it can be a way to gather them. But the problems are several, and data quality can be low. Data requires validation, and validation does not publish. So how do we help citizens create good data? What we came up with is the matter of a process, defining a well-defined process to help the people work on data. What do we mean by that? I mean that we have to teach the process, not just a tool, and that's bad. But on the other hand, we have to force the process with a tool. Why do we need to do that? Because we have three problems. Data structure problem. We have horribly unorganized data and organized data. And I will say something that is that let's say it's controversial. Wikidata is not structured data, is faked unstructured data, because you have to know which connections have the informations have, and if you don't know them, it's basically unstructured. So Wikidata is way more to the unstructured area than it is to the structured. Obviously, with common knowledge things, I totally agree, it's structured, but it's complicated. We have the problem of data accuracy, and we have a problem of, again, from Wikidata, Battle of Salamina extends battle, and the Battle of Gettysburg is a battle. It's a mess. It's nice data, it's good data, but sometimes when you look in the details, it feels strange, and from a development point of view, it means a lot of work to be managed at the end of the data harvesting and data usage. What tools are there? What tools are good for? In what part are they good for us, and in what part are they good for the users? We started looking at the most important ones, and the two tools that we started working on in the last years. Wikipedia, no structure at all, has an average accuracy depending on how the people interact with it, and it has an average quality. But the problem is the average to bad learning curve, that you have to learn how to write and and the community is always a bit picky on the ways you describe things. Wikidata has a good structure in the end, because if well written, the structure is good. Has an average accuracy and quality depending on, again, the user that interacts with it. And it has a horrible ease of use, because you have to understand the meaning of subject, relationship, and object, and the sub details, and the metagraph that is connected to it. And it's technically, as a technician, it's beautiful, but for the end user to understand that something is something else, and to think with simple phrases, is a mess. OpenStreetMap has a great structure. An average accuracy depending on the availability of data and on the creation of the communities. Problem with quality, yes, depending on the areas, because some areas have a good quality, some areas have and to write on the let's say the quality and ease of use are connected, because when you try to put data into OpenStreetMap, if you don't read the wiki, you will be killed by the community. And so you start digging into the wiki, and you start to understand how complex the whole structure of OpenStreetMap is, and the result is complicated. Then there is Pybossa, which is a platform for citizen-driven citizen science, basically, where the users can help digitize the information. The structure depends on what the research topic is and what the research question is. The accuracy is high and the quality is high. Why is it so? Because with PyBossa, the research question is generated according to a specific form that is created on the platform for that specific research question. So that means that in this case, the accuracy is high because the user cannot do wrong things, because he is very limited. He is on a very strict path where things can happen. And the same goes for quality, because the researchers can define limits to the data that can be inserted. You cannot expect some, I don't know, some information to be completely out of certain bounds. Perfect. It makes sense, and the structure gives you the possibility to have a well-defined general system. It's not easy to use because it's a structured form and it's a complicated way to interact with things. In our case, we started working on the public history toolkit, which is a tool that we'll present later with the main part that is already covered, that is the gazetteer tool in one of the later sessions, and the transit of the past platform. They're both tools that are aimed at creating data with the citizen. That's in the first case, for example, we have a process, and we defined a process where the user has a very limited amount of operation that he can do, and the operations are well defined, and I can show you the screenshot. The operations that the user can do is he selects an area, he selects one of the maps or the maps that are chosen for the activity, and the user starts connecting the points and labeling the points. And there is not a way he can do something wrong. Those are the points. The data sets that are connected to those points are well defined, come from Wikidata, come from OpenStreetMap, because they are labeled places in the city. And we get to a data set that has, if the user is not crazy and starts clicking on random points, obviously, if the user uses a bit of let's call it common sense, the data quality is automatically average to good. And this means that we need just to validate the general quality of a few data sets to have an overview of how the system how the system changed. So what if we start, instead of having people answering our research question, we start giving them a process to follow. We make them part of the process, and we start giving them tools to be part of the process, and not giving them generic tools just to avoid the process. By this, I also mean, for example, writing tools that help us write on Wikidata. For example, forms that write on Wikidata, but with well-structured infrastructure around it. So non-specialist users use the platforms, give us usually a very harsh but realistic feedback, and we got that with this platform. The first version was way more clunky and complicated to use. You had to click on 3 parts to start adding points, and click once and add a point, click twice, add another point. So now it's easier. So you have to follow the steps that are due. So you don't have to do 15 things on one after the other. And the things you do are well defined, well structured, and you cannot do wrong steps. Again, if you do things in a sensed way and you don't start clicking the random points. So yeah. The big question is, shouldn't UX UI designers get into the discussion? I know they cost a lot, but they are the ones that you're lucky. You're lucky. You're lucky because it's usually complicated to have them to get into these kinds of projects because of the budget that is usually so high. They usually say, no, I don't want to come because there's too much money involved. Yeah, and this is dreaming. So yeah, that's the main. This is the main topic of the discussion.
Thank you.
Thank you.
Thank you so much, and sorry for this exchange. Okay. We are ready.
Are we sure? Okay. Hi, good morning. I'm going to show you the Medianene project that has involved many professionals in the academic and museum worlds. The purpose of the work is to illustrate the workflow, methodologies, and the impact of the Medianene project carried out through the collaborative use of Wikipedia by ArcheoFOSS Association. The project is the first operative experiment in building knowledge infrastructure from below by the ArcheoFOSS Association. Being a legal corporation has in fact guaranteed the possibility of assessing funds for enhancement, a collaborative activity that has seen virtuous synergy with other Italian and international free knowledge operators, such as the Wikimedia Italia Association. In the new ICOM definition approved at the General Assembly in Prague in August 2022, we can see how there is a change of perspective and the introduction of a new terms and activity that show the new direction towards greater participation and knowledge sharing. In this point is the key that can provide for different ways of sharing, and then in the project we present today, we see the open aspect of Wikipedia and the possibility to sharing knowledge and information to a large audience with the even active participation of users. The importance for a museum to be on a such platform and especially to manage page, having scientific control over the information is fundamental for the dissemination of knowledge, especially in the small museum, in small community that we all be able to approach through a platform widely used for research, also for travel or visit, and for new potential audiences to have update and shared information. The project fits into this framework. The aim of this project was the creation or implementation of the Wikipedia page of the Museum of the Medianiane Valley, paying particularly attention to the photographic documentation. It was important to update the page and especially the photographic material to reflect change in exhibits and collection on display. There are 7 museums involved in the project, which are part of the Medianiane Museum system, and which have together in this system to create greater interest in the area and the enhancement of local culture. The purpose of this project is over and above the creation of the page and the photo campaign to allow greater knowledge of the area through a series of report and data disseminated through free sharing. Publishing cultural content can provide additional benefits and expand the visibility of local museums. Wikipedia is the largest open collaborative encyclopedia online, the place on the web where anyone can create and improve content. The project began with the specific training of the working group. In particular, the issues inherent to the free and open source software, which govern the Wikipedia and open world, and have an information collaborative networks of programmers were addressed. The source code is licensed free of charge, encouraging modification and improvements. In addition, the writing for creating a new or even editing existing page must follow strict writing standards. The organic and relational arrangement part focused on Wikidata was the endpoint of a learning and dissemination journey. After a specific training, we proceeded to analyze the territory and the type of digital communication of the museum. In addition, there were several meetings with the director and staff of the museum in order to define a homogeneous work plan and discuss what kind of material to publish. In fact, the survey process also aimed at meeting, getting to know each other, the museum, and getting involved in writing or editing page of the museum communities of the Medianiane municipalities. All the museum communities visited provided to be extremely helpful and proactive in helping and studying ways of publishing materials on Wikipedia. The survey also aimed to collection high-resolution photographic material of the settings, room, and the items displayed in the museum. The goal of this operation was to renew the presentation of museum room on the web, show in high resolution the details, variety, and cultural quality of the museum object on display. Among the many images, photos taken during the survey, those most communicative and useful for the purpose and presentation of the museum were chosen. After selection, the images were uploaded and metadata on Wikipedia Commons, specifying the author, place of shooting, right of use, and the images. Wikimedia Commons is an archive where you can include the multimedia elements such images, videos, or sounds. In order to upload multimedia materials to Wikimedia Commons, one has to go through a careful metadata and image use right recognizing operation uploading. When necessarily required, the permission signed by the editor, allowing the publication of materials and photo under the CC by CE 3.0 license. Finally, the images were associated with the Wikipedia page. As mentioned, Wikimedia Commons allows to create logical structure by which, with process, you can find the related search results. The information is then hierarchized. The same operation is done for the data. They can be structured in a database, which is Wikidata. Here, the information is structured in a relational way. In the tabs, there are properties that are retrieved based on the search until you get the more specific characterization. The project team undertook the task of creating categories for indexes in Wikipedia and on the web of both page and content regarding individual museum. This was useful for future updates and for speeding up the search of Wikipedia page via the various search engines. These indexes will also be useful for future argumentation of images and information, also by the museum or communities themselves who wish to contribute. Once the entries, image, and the rights were corrected, categorized and metadata, the wiki page of museum were published. The final operation saw the creation of the page and their publication in chronological order or work closure. The researchers who participate in the creation of the page sent their sandbox to the coordinator, who proceeded to the final review and final publication. So this is an example of Wikipedia page we edited. Practical logistical information for visiting the museum has been added, as well as described the history of museum inception, origin, its collection and artworks, and showing the new museum layout, which was not in the previous page. In conclusion, the creation of Wikipedia page dedicated to cultural, natural, and historic place provide an opportunity to learn more about the cultural heritage in open digitally way, leading to increased awareness on the part to visitors, but also in the local community. So the goal of the work is to improve communication and increase the visibility of this museum by providing scientific information to the public in open access mode, and to build our relational infrastructure such that informational is linked. So by visiting the page of the museum, the user can get an idea of the exhibition and the collection on display. So it become interested in actually visiting the venue or contest area. And publishing cultural and content on Wikipedia can provide additional benefits and expand the visibility of local museum. And thank you for the attention. Okay.
Please remain, please. Please remain. We have the discussion. So we will finish with some minutes of discussion before lunch, and in our section you can see that we have a meeting between who is working on the dataset analysis and makes the data really impressive, like Thierry and Marco Montanari, and who is working in involving local communities to do data sets and to do data. And collect and increase the open knowledge it is so important. And then I have some questions. If no one wants to speak, I can for you, of course. And I have just one question for Thierry and his group. How much the community it is important for the creation of these really interesting data sets, and how to help in the creation of new data sets such as the Terra Sigillata Samian data. Can someone helping in
Florian, so let's say something.
It is just a publishing problem. It is just up to publish in open access new reports of ceramic ware or similar.
I think so. There are two possibilities. So one of them is in the Samian research database, where Alat can say something about that. And yeah, with the Wikidata, somehow the Wikidata idea behind it. Maybe Brady, you can add something. But Alat, if you want to start, how the community may integrate data into Samian research somehow.
So what's happening is that we have organized workshops throughout the whole of Europe, because the material is distributed also throughout Europe. So you have groups working Croatia, England, or Portugal, wherever, and we organize workshops on the spot there. Well, so in the central place of such an area, where people learn how to enter new data and curate things. Can also be done. And this is done in a specialized DOI, as the subject which was mentioned before in the other lecture. And this is, of course, a very important issue to give such interfaces at hand to this large community. I think we are somewhere 120 different archaeologists who have passwords and full editing rights to this data set. And that makes it so dynamic. I think the clue is that it is a very, very open system already in the data capturing databases, Postgres database at the end with a web interface in front. So people are more or less completely responsible for their own data. And because there is a set of exploring tools combined with this Samian research database interface. So if people, let's say, fill in the data and they mix up the coordinates, let's say the latitude, longitude, so they're swapping these. When they make a plot of their stuff, they will find the thing being plotted in Mozambique or something. Yeah? So there is a win-win situation that people will fill in the data correctly if they can do something with it. And so we are offering a basic set of exploration tools already in the data capturing phase. And from then on, it is then exported towards the Wikidata world, where, of course, the core curating group of people don't have a real influence on what further properties are being added or whatever. Ready.
Thank you so much. And if someone
maybe Brady could add something on that. So
my fundamental point is that Wikidata is a tool by which a much broader audience can be alerted to the concept of Terra Sigillata and to this enormous multi-generation research task. And for me, that means the archaeological site of Pompeii, its web presence should be connected to the Wikidata expression for Samian ware. You know, it's a minor point, but it's so merging entries to maximize the value of each Wikidata item and send people directly to your site in a way that's where they can see at a glance, you know, what the presence of the material is. And let me just go on to say, for museums, each major item in a museum should have a Wikidata item for it, including the coordinates, not only where it is now, but where it was found, at least for archaeological things. That allows the finds in a museum to be reimplanted back in their original landscape. So a person who goes by the find spot of a monument can say, oh, that's now in the museum, and pulls people there, and also brings the monuments out of the museum to where they were originally.
Yes, of course, you can.
Yeah, hello. Thank you very much for your presentation. I have two questions, actually. The one is to your group online, which is, have you thought about the granularity that you want to actually add? Because I feel like Wikidata is just this hub of like, okay, there's places, and you said there's original places, there is buildings, you mentioned there's Clepion, and there's items in museums, and somehow this becomes all part of this knowledge hub, which I think is a really great basis. But also, in the end, I feel like there might be an additional layer. Then we start with a new ontology, pretty much again, to map this new data that's coming now from Wikidata. And there's an added level then of difficulty, which brings us back to our scientific systems that we already have. In some senses, at least. So we have like some gazetteers and some norm data floating through some universities or research institutions. So have you thought about the granularity is my question for you, and then more generically towards input systems maybe, because I feel like what we heard from the MapHot 4D, from you, Marco, and also for the Wikidata, I feel like we're saying, okay, the users want to add data as simply as possible, and they don't want to do anything wrong. And also they want some basic exploration while they're adding data. And I feel like that's exactly what the scientists I work with want as well. So I feel like I'm not sure if the systems from scientists or from the general public are actually that different. So maybe any of you want to comment on that.
On granularity, my preference is, if you have granular information about a find spot, you should keep it. That means if the Terra Sigillata was found in the Asclepieion at Corinth, put it in the Asclepieion at Corinth. I know this requires some adjustments in the database of the project, and I apologize for that, but I think in the long run, you need to have the ability to subdivide where necessary and rejoin where necessary. Am I terribly wrong?
I think a lot of this stems from who is entering these data. We have nurses or pensioned custom officers and archaeologists who are entering data. An archaeologist may be vaguely aware that there is an issue with a site like Corinth, but the custom officer thinks about his last Retsina he had in his holiday somewhere in Greece. So already on the entering level, I completely agree. But the basic thing is that you have this thing recorded at all. That's already a basic issue. For a lot of things, we are happy that we have some kind of reference to this this guy, shirt or whatever, in somewhere in northern Africa. And there are other ways to do research on what we call Provenienzforschung in Germany. You have to then to look at the history of the excavation site and so on, why or where could it have really been found, you think, whether it's something's only said Tunis, or, yeah, can be anywhere. So it's a whole wide scale of data quality issues when entering, but I wouldn't refrain from restricting entering data to archaeologists only. Our experiences are just too good to not to leave that path, and we need the community. But you can already use citizen science when entering stuff into so-called professional databases. That is the point I would like to make.
And just one more thing, so which leads also to the next one. Also can see in the room right now. GUIs and whatever tools to enter data. So there are some tools for Wikidata to enter them, maybe Cradle or whatever. But as said in the talk, you have to know somehow the structure already. If you have a form where you can have some drop down and whatever things, but if you do not really are interested in the structure behind that, it's always some kind of impossible to add good data. But yeah, that's the same for everything, not only for in archaeology. So maybe, yeah, just want to add that. And I think in the room there are some more discussions I can see.
There is a small technical problem, no problem. I wanted to give an answer to the question that you posed. I agree that both the end user community and the technical community obviously need tools. Most importantly, once the processes are defined. As long as you, let's say, start in a blank field, obviously the process will evolve from the needs coming from real life situations. So, and for that reason, we cannot avoid having both interfaces: the unpleasant Wikidata brutal interface, and at the same time something nice to store data in a system that then transforms it into something that is useful for Wikidata or any other platform. But the most I think it's a process that, again, it's a process that is one step above all the other kinds of processes, and it's a matter of being aware of the complexity of the data structures behind the systems.
Thank you.
You're welcome. Thank you.
Thank you. So as you can see, we have some technical problems, but just because I want to try to make a different view of our camera, but I opened the screen. So no, I want to say another thing. Again? Okay, perfect. So I want to thank you, Roberta Manzolino, for your contribution. Just because it is for your work that we have this 2 beautiful days. And have you meet your local community, and are they involved in your work, and how? Just this. And then, of course, we have the lunch. We have Anna Marras and then the lunch.
Yes, the directors of museum and local communities, also the operators of the museum, such as the association we work in there, were involved in the writing, and they provide us the materials to publish, and we also rearrange the text and publish. And so the local communities are very happy to be visible on web.
Thank you so much. And now we have just a moment for Anna Marras, and she can be with us.
The camera is now working fine again, so it's.
Ciao Anna.
The camera is now working
Ciao.
fine again.
Hi. Ciao Anna.
The camera is now
Hi.
working fine again.
Hi.
Could you hear me?
Yeah, yeah. Ciao Anna.
Ecco.
The camera is now working fine again.
Hi.
Could you hear me?
Yeah, yeah.
Okay.
Ciao
So
Anna.
it's I had a problem with my audio. Could you hear me?
Yeah, yeah.
Okay. So it's I had a problem with my audio. Could you hear me?
Yeah,
yeah. Okay. So it's I had a problem with my audio. Could you hear me?
Yeah.
Okay. So it's I had a problem with my audio. I don't.
Okay.
I had a problem with my audio. I don't.
Please, if it is possible to mute the microphone of Anna Marras. Okay. Now we can try to talking about something of really important of the future for the future of ArcheoFOSS movement with you. You have a proposal. You can hear me. Okay, okay. Can make this moment after lunch. Okay, so see you later. See you later, Anna. Okay, at 3 o'clock.
Conference work will continue at 3 o'clock. Anna, we'll talk together and fix another moment. I'll have a technical test probably before. Thank you.
Okay, welcome to the afternoon session of ArcheoFOSS, and we need to make a small announcement. Please, Gabriele Gattiglia, the president of ArcheoFOSS Associations. Okay.
Thank you very much. Welcome to everybody. I'm here on behalf of Anna Marras because of the previous technical problem. She would like to suggest as the next place to hold the ArcheoFOSS 2023, the city of Turin and the University of Turin. So this is the new location candidate to hold our next meeting. I'm very happy, and I will thank a lot Anna Marras and the University of Turin for allowing us to hold this conference next year in Turin. I think we could accept this offer. Otherwise, if someone else wants to propose another location or university for holding the meeting, is welcome as well. Thank you very much for your attention.
Okay, we can start in perfect time. So. Okay, so we decided to start this panel in a different way than the previous edition of ArcheoFOSS because we call a data scientist who deals with contemporary times to introduce the topic of mobility data. Because me and Noemi think that archaeologists, historians, and all those who deal with the past and mobility-related studies and behind have a lot to learn also from those who work with data from the present period. So that is why we welcome to Anita Grazer. She's an expert in spatial data science for mobility and transport applications, PhD in applied geoinformatics at University of Salzburg, and she works since 2007 in applied research on spatial analysis on transport and movement data. And she's currently serves on an open source project, QGIS and MobilityDB, and she's the lead developer of the open source software library Moving Pandas. So please, Anita, we are so happy to have you here today.
Thank you very much for the invitation. I hope you can hear me well.
Yeah, yes, please.
Okay, excellent. So I'm really excited to present here. As you correctly stated, my background is not at all in archaeology, but I find it very interesting to think about the overlap of our domains, and let's see where we can take it from here. The movement data that I've been working with over the last couple of years is really diverse, and in general, the whole field of what we may call movement data science is extremely diverse. If you think of movement, quite often we think of maps, of course, but it already starts with the number of dimensions that we are considering in our movement. For example, if we have flight tracks in 3 dimensions, we might have to use different approaches than if we work in 2 dimensions alone, as we do so often in GIS. A completely different kind of movement that is not really geographic in nature, but still it could be considered movement data science, is if we look in eye track tracking research, where researchers are interested in where people look and for how long and how they switch from different positions in the image, as you can see in the upper right corner example of a trajectory of eye movement. Another related area which could provide insights is the whole field of sports analysis, where really analysis of soccer matches are just one example that has gained a lot of research interest in the last couple of years to try to understand the performance of the teams and how certain situations are playing out, what strategies they are following. And last but not least, of course, movement data science is not limited to geographic space, as in geo, as I'm staying on Earth, because nowadays we even get tracks and movement data from other planets, like the Mars rover and its companion helicopter trajectories that you can see in the right-hand example. So all these different places and contexts make mobility data science such an interesting field, in my opinion. Now, if we look into the commonalities or maybe the differences of historical movement data and what we have now as contemporary movement data, I think there are quite some similarities. Of course, just a couple of decades ago, you would not find any GPS tracking information naturally. So maybe the most common and most widely used kind of movement data is, of course, very, very new. However, the whole concept of trajectories and routes, whatever you may call them, is of course not new. Cartographers have been recording that travel routes of ocean-going vessels, of caravans on land for many centuries. So this is one field, this kind of tracking data, if you want, with different spatial accuracy. So while nowadays, if we do GPS tracking, we maybe have an accuracy of plus minus 10, 15 meters in most areas of the world. In the past, we probably only knew a couple of sporadic stops where people would go, and we have a rough understanding of the route. That's why I'm really excited when I looked in the agenda of the panel to see this talk proposed on LiDAR dataset analysis, to see where these routes may actually have been, and to extract this route information from this kind of alternative data sources as well. Because the road network or the path network that is available for the movement is the second complementary information that has to be considered in most movement data analysis. And here I also see a lot of commonalities between what you can do with historic data and what people do with nowadays examples. On the right-hand side, for example, you can see the network of Flixbus, this one company who organizes bus trips throughout Europe, where it visualizes which are the most prominent routes with those wider lines between the nodes in the network. And you can see like how Europe is connected by this bus network. So really, I took the title of the panel to heart, and I was thinking of what are some of the open solutions for doing movement data analysis. And you really have two large groups of tools that usually are separate, but might work in conjunction when you are performing your analysis. However, on the development side and on the methods that you need, they're quite separate. So I want to talk about them on two different slides. I want to first start with the tracking data because it's near to my heart and also to what I've been working on the last couple of years. As Noemi and Dominic already mentioned, I'm the developer of Moving Pandas, which is a library that works with this kind of tracking data. So mostly GPS tracking, but could also be eye tracking, sports tracking. And some related tools that do similar stuff. There's some overlap, a lot of different functionalities as well. Would, for example, be Scikit Mobility and the Meus library. So these are for people who are interested in writing code, who like to use Jupyter notebooks, and don't necessarily need a graphical user interface. Basically, I saw that there's a lot of examples in the proposed talks today where QGIS or QGIS plugins were used to do the analysis. So far, there are not really any good plugins for QGIS that deal with this kind of data. For me personally, from the Moving Pandas side, I can say that that Moving Pandas started out as a QGIS plugin, but then I realized I had to work much more on the underlying data structures and methods before I could advance to a QGIS plugin. So that is still on the to-do list. And I guess many other developers feel in the same way. On the other hand side, if you are interested in a solution that works for storing the data in a way that is more convenient than just plain old shapefiles, which don't know anything about the movement and how things are actually related to each other, then I would recommend you look into MobilityDB, which is an extension for the PostGIS database that is aware of the characteristics of movement data so that you can actually store your tracks, your trajectories as proper objects instead of just a series of points that have no real logical connection on the tool support side. Of course, these are just a couple of examples of these kinds of libraries. And if you want to see more, I strongly encourage you to visit the GitHub link provided on this slide. There you will find a lot of other Python libraries, but also if you're more into R, there's a long list of other available libraries that can be used for tracking data and for different kinds of analysis. Like if you're interested in privacy related concern, have a look at Scikit Mobility, which provides a lot of measures, which makes it easier to quantify how easy it would be to breach the privacy or to identify individuals from a given data set, for example. The other set of tools that we need in movement data analysis are tools that can deal with network data. So if you have a path network, roads, rails, or just logical connections like the Flixbus example, which doesn't really show the details of the routes, but it shows which places are connected with what other places, right? Then you have access to a whole other family of tools, including such which work with services, so you don't even need your own network. You can use public providers, like, of course, like Google Maps, Google Routing would be one of them, but there's also Open Route Service tools plugin, which you can see here in the lower left corner, or HQGIS plugin, which is provided, which uses the Here API or the Travel Time platform. So these would run on a road network that is up to date and cannot be influenced by the user. It's a given, but it's really easy to use. You don't have to set up anything. On the other hand side, if you want to use your own network, you can do that through the standard network analysis tools in QGIS already. You can compute, of course, shortest paths between points, between two different layers of points. You can compute service areas that show you which region would have been reachable from a certain point in a given time or in a given distance. Something related that you might find interesting, because I also saw that you will have a presentation on a variation of GTFS, is the GTFS Go plugin, which is the plugin that is used to create the visualization you see on the right. So it takes the Google Transit feed files, which contain information from public transport schedules and routes, and gives you this nice geographic visualization of the connection. And I think that could also be interesting for your historical data. And if you really want to work with your more detailed road network, path network, another option would be the QNeat plugin, which also lets you work with your own network data and have full control over all the things. Outside of QGIS, of course, we again have extensions for PostGIS. So if you already have a database, PG routing, and the related QGIS plugin will be of help. And to go full circle again, because in the previous slide I started with the programming tools, with the libraries. If you're looking for a library in Python that can do network analysis, then the good candidates would be NetworkX or the new R5Pi library, which give you complementary tools for working with network data in programming environments like Jupyter Notebooks, if that is something that you want to dabble in. And I really encourage you to have a look into those. I didn't see any examples in the upcoming talks that would have been obviously prepared in a Jupyter Notebook. But I think it would be worthwhile to give it a try, because it really helps in making research more reproducible, easily shareable, at least easier than in the classic workflows if you use a graphical user interface desktop GIS. And what you can see here, of course, is a contemporary example where I'm writing code with moving pandas that shows a route and that detects the stops within this trajectory. So basically where the person or the moving object was stationary for a certain amount of time. And you can see there's not really a lot of code to write. It's almost all visible on the left side of the screen. However, this already enables you to have an interactive application like the one that is now shown in this animation, which makes it possible to step between different trajectories, change the parameter settings of the stop detection algorithm, and it gives you this interactive map and the table to explore the data, to better understand what it is about. So if you have some Python skills, or if you're interested in learning those, and if you see the value in reproducible science, I think giving those libraries a try in Jupyter Notebooks could be a real boon for your work as well. The visualization options are really diverse. Here are a couple more examples of what I did with moving pandas. So on the left-hand side, you can see migration trajectories of birds between Scandinavia and Africa that I aggregated so that you can see the most popular paths that these birds take. While on the right-hand side, you can see an example of sports analysis, where I added not a classical map in the background, but just an image, the soccer field PNG file, and I plotted the movement of the players on top of that. So that's also possible with these libraries. If you have coordinates that are not geographic, but just relative in space somewhere, we've got you covered as well. If you want to hear more, there's a couple of presentations over the last years that have been recorded that I invite you to watch. And of course, check out my posts on movement data in GIS if you want to learn more. And with that, I want to thank you again, and I'm looking forward to seeing the panel.
Thank you.
So thank you, Anita, for being with us. You're such an inspiration for us. And we are sorry we couldn't have you in the final discussion, but your talk was such inspiring. So yes, it was planning Dimitri's talk now, but he wrote us yesterday that he will be unable to speak today. So let's go ahead and we will move on to Maria Deng's next talk, entitled Viabundus, Map of Pre-Modern European Transport and Mobility. Maria Deng studied archaeology, medieval history, and anthropology at the University of Heidelberg. After her master thesis on the continuation of Roman roads in early medieval times, she worked as a researcher for Middle Germany in the Viabundus project. Since 2020, she is working on a PhD on pre-modern travel infrastructure. So, Maria, can you hear us? Okay, we can't listen to you. Unmute the microphone, please. Let's check your microphone. We don't hear you. Sì, ok. Quando è entrata? Ok. Ok. No. Ok, no, ce l'ho attivo, ma non...
Could you check permissions from the browser? Yeah, that's all. And any hard switch?
Okay. Mm-hmm. Sì.
Okay. Probably you can take some time, Maria, and make some local tests with another microphone or so, and we can switch to you afterwards. Thank you.
Okay. Okay, the next talk is by Alexander Diachenko and Ivona Sobkowiak-Tabaka. I hope the pronunciation is correct. And it is entitled Small-Scale Movement, Tracing the Intrasite Relocation of Hunter-Gatherers. I think we have only Ivona here with us today. Ivona is a university professor of archaeology at the University of Poznan, Poland. Her research focuses on the issue of late Paleolithic communities from the North European plain, especially on the relations between humans and environment. Her ongoing research covers transformations and modifications of culture in prehistory. So welcome, Ivona.
Hello, everybody. I'm very happy to be with you. Unfortunately, Sasha couldn't attend the session, so on behalf of our small team, I will try to present our work. I do not have well connection, so I will stop the camera, okay, and will try to I'm not really sure how to share. Okay. Slides. Computer. Okay.
We don't see your screen.
Uploading, so I hope that everything will be okay. Processing.
Okay.
Share slides or share screen?
Screen.
Share screen. Okay. What next?
On the preview screen that's appeared in the pop-up window.
Okay.
Click on the preview and then click on share. Blue
Yes?
button probably. Yes. Yeah.
Is it
perfect.
visible?
Yes.
Wow.
Yes.
Thank you very much. Okay. So the title of our presentation is Small Scale Movement, Tracing the Intrasite Relocation of Hunter-Gatherers. Let's move. Organizational principles of the open-air Paleolithic camps are often approached with Binford's model, as you can see on the slide. His observation on the Nunavut suggests that the changing of wind direction causes the relocation of people from one fireplace to another and back again. Despite the general criticism of... Yes?
You have to present the slide. Move to the next.
Should be the next slide is the issue. You don't see?
Okay. Sorry.
Okay. So despite the general criticism of ethnographic analogies expressed since the manifesto article of Wobst, as well as the doubts expressed about the level of practical necessity in the organization of a new herd in the case of this model, still Binford's model is being actively applied to the camp structure of archaeological hunter-gatherers. The fundamental concern with such an approach is the axiomatic consideration of closely located flint clusters, which include traces of herds, as being simultaneously functioning. This is especially the case when items found at different concentrations had been refitted. Simply saying, Stone Age experts often consider a kind of occasional ghost movement of people between synchronously functioning flint concentration. In contrast to the hypothesis of contemporaneous concentrations, our paper presents a model dealing with the smaller scale movement of archaeological hunter-gatherers camps based on curation of blade and on patterns in wind direction captured by special distribution of fire at the archaeological sites. Our model is based on a simple assumption. Considering the curation of artifact parts, we assume that people relocate within a site moving artifacts with them. Quantitatively, this may be captured through zero-sum distribution of artifacts. Our null hypothesis is that a simple sum of the withdrawn blade parts indicates no curation. The null hypothesis states the lack of artifact curation, supposing no people relocation, and therefore questioning the synchronicity of the concentrations within a site. As any null hypothesis, the suggested one is graph. This means that synchronicity requires additional arguments and relocation of people requires more evidence, etc. What is important with any null hypothesis are the cases when it is rejected, even given it is oversimplified character. So now some examples. Let us provide you with a better explanation of the null hypothesis using the following somehow oversimplified example. Assume a camp composed of flint concentration A, B, and C, with the blade parts distributed as presented in the upper table. In total, our hypothetical sites counts 200 proximal blade parts, 100 145 medial blade parts and 90 distal blade parts. The minimal number of the withdrawn blade parts at the site is a simple mirror reflection of what we have. In this case, the number of withdrawn medial parts counts 55 and the number of withdrawn distal blade parts counts at 110. Hence, following the null hypothesis, we know that the overall campsite lacks middle and distal parts, and their overall number may be obtained as a simple sum of what is missed in each concentration. Concentration A lacks 30 medial and 50 distal parts. Concentration B lacks 5 middle and 10 distal parts, and concentration C lacks 20 middle and 50 distal parts. A simple sum of the withdrawn artifacts per concentration is equal to the site-scale number of withdrawn artifacts. Therefore, the null hypothesis is confirmed, showing no blade parts curation and perhaps no relocation of people with a site. Now let us interrupt such a simple quantitative image, moving 10 middle parts from the concentration C to the concentration B, as presented in the table. The mirror reflection of what we have is what was withdrawn from the sites is presented below. The site scale number of the withdrawn middle blade parts counts at 55, while summarizing the withdrawn middle parts per concentration, we unexpectedly end up with 35.
Sorry, Ivona. Sorry. We're stuck at the first slide. We're seeing.
But I have the sixth.
Oh yes, but we are stuck at the first. So
what should I?
Yes, we see your mouse, but could you click on the left on the second, on third, and etc.
Yeah, but I'm doing that.
But could you do it again now? The second one.
Second one, third
yes.
one, fourth one.
Oh. So you've shared this. You've shared the screen or the.
Yes.
Are you using Echo? That's okay. We're now at 5, number 5. Okay, probably it's working now.
Okay.
But I can't move the slides now. So this is the 5th. Yes. And I can't move the 6th. Sorry.
Okay.
I don't know what's going on. Before everything was okay for me, but
we almost see the 5 slide.
Is the 6th now?
Okay, yes. Okay.
Sorry for that. So, yes. The null hypothesis is not confirmed, suggesting the relocation of artifacts from the concentration labeled with minus to concentration labeled with plus. Our artificial movement of 10 blade parts tell us about issues with artifact sums when dealing with actual empirical distribution of artifacts from archaeological hunter-gatherer camps. If you summarize blade parts not accounting their location and then summarize blade parts per concentrations, ending up with different values does not mean you are weak in counting. What it means is that you just identified artifact curation. Of course, blade parts are also found in cultural layer outside concentrations, and those are made on blade parts. This is what we took into account dealing with actual distribution instead of hypothetical, oversimplified examples. So slide number 7. Of course, zerosomes are still there in our hypothetical example. We know that we simply moved 10 artifacts from C to B. Real situations are more uncertain. Plus marks additional artifacts at B, meaning that the middle part were brought from A, from C, or from A and C. And this is why we need more evidence on directions of artifact relocation. Moreover, it is obvious that relocation of artifacts doesn't necessarily mean relocation of people. Therefore, we need more patterned evidence to go further. Our solution is taking a look at the spatial distribution of fire within a camp. So slide number 8. More evidence to analyze requires more underlying statements to be made. These are as follows. So the first one, people relocate because of waste accumulation. Second one, accumulation of artifacts in respect to a fireplace indicate wind direction. And the last one, relocation of people because of the changing wind direction and waste accumulation corresponds to the direction marked by the artifact curation, or curation minuses and pluses. Let's move to the case study, the site number 10, Lubja. It's Sphiderian, so I mean late Paleolithic settlement. Artifact curation is presented in a table. Among various methods dealing with the spatial distribution of fire, we have chosen for nearest neighbor statistics. What artifact curation and changes in the wind direction tell us about smaller scale movement of the Sphiderian people in Lubja 10? The spatial distribution of flints suggests a southeastern wind in case of concentration 4, 5, and 6, I mean unit 2. A southwestern wind in case of concentration 10, and northerly wind in case of concentration 12. Concentrations 7, 8, and 9, I mean unit 1, seem to demonstrate the change in wind direction from southern to north, northeastern, or vice versa. Unit 1 and concentration 10 are considered to be contemporaneous to each other and detecting the arrival of the Sphiderian group to Lubja 10. Due to highest value of middle and distal parts of blades lacking in Unit 1 and to similar trends in wind direction in the concentration and the unit. Moreover, two distal parts of blades were brought to concentration 9 from concentration 7 or 8. With a change in wind direction from north to the southeast, the Sphiderian group organized a new activity area and new domestic space represented by concentration 12. The number of middle parts of blades exceeds the expected number in Unit 2, suggesting that the majority of blade parts were brought from Unit 1. Similar trends in wind direction suggest the simultaneous activities represented by concentration 12 and Unit 2. Thus, our model indicates the smallest scale relocation of archaeological hunter-gatherers, also allowing to construct microchronologies of Stone Age open-air sites. The mathematical component of this approach developed in our aerial paper has scale invariant properties and hence may be applied not only to the intra-site analysis but also to the site clusters if you have enough data. And more details may be found in those papers. Thank you very much for your attention, and I'm very sorry for these technical problems.
Thank you. So, we have Maria.
Hello?
Hello.
Oh, great.
Okay. Okay,
Very
well.
good. Okay. So let's try this again, shall we?
Okay.
Okay, so I was introduced already. Thank you very much. And I'm here as a larger team, in fact, of the Via Bundus team. We're spread across Europe. We're in the Netherlands, we're in Denmark and Finland, and I'm here today as a representative to talk to you about Via Bundus, our map of pre-modern transport and mobility. And we are a project that started in 2019, and we've been ongoing until today, basically. We released our version 1.2 2 days ago, which we are very proud of. And I'm here to show you what this is all about. So, what was the idea behind Via Bundus? So it all began at a coffee break at a conference where some people came together and thought it would be a great idea to digitize the Atlas Hansische Handelsstraßen by Friedrich Bruns and Hugo Witscherka, which is a big work that has a lot of roads in it. And since it's only analogous, they thought it would be great to have it in a digital realm. So what we wanted to do was create a digital basis or a databases for the analysis of economic historical processes in Northern Europe, which was the extent of the Atlas in the time of the Hanse. But it was also the intent to create a basis for research projects for third parties. And so from the very beginning, it was the idea to have all data all open access. So where did we get our data from? The starting point is or was the Hansische Handelsstraßen Atlas, as you see in the upper right corner, and to put this onto a digital map. And we soon realized that we wanted to have a smaller scale, to have it more detailed than the atlas itself. So we turned to historic maps and also to secondary literature, especially local studies. So we're a regionally working project, and therefore the database is very different. So in some places we do have secondary literature and also archaeological data. We have people who have analyzed LiDAR data. We have open source LiDAR data for some parts in Germany, but not others. So the data basis is very diverse. And since we also add additional information on our places, we used lexical manuals and archives. But how do we actually work? How did we put the roads and routes on paper, so to speak, or in our GIS in this case? So first of all, we thought of our map as a network model. So we think in nodes and edges, the nodes being basically any place where anything happens, and the roads being our edges. And this is QGIS based, and we had some guidelines. So we wanted to map our roads as detailed as possible, but at the same time, we had to keep in mind that we would not be able to work on such a grand scale and have the roads in topographic exact order. So from the very beginning, we had a ideal that said that we would map routes before roads, meaning that we would map the place from A to B in a more general sense, and that there would always be more roads leading to a place than the one that we put on the map. We also wanted to include navigable inland waterways, so not every waterway, as you can see on the left side in Bruns and Witscherka. We only wanted to include waterways where you could use a boat, basically. And then we wanted to include all settlements that were or are towns. And then we had additional attributes that we thought were interesting. And you can see the attributes on the right here. So we have fares, staples, and tolls. We have bridges, ferries, harbors, and locks that we also added to our database. So here you can see a glimpse of our data structure. So we entered all the data into a SQL database, and the output is done via leaflet, which you can also see online now. Being an ongoing project, this is of course connected to some challenges. So we are a living data set. We have a regional approach, and this means that data is for now not complete, that it's also different for different regions, as I already mentioned in the beginning. And then there are very different challenges also for the region. So there are seasonal influences which are very prominent right now in our Finnish project, where different roads were used in the winter than in the summer. There's a whole different road system, but there are also temporal dynamics. So of course we can take into account every skirmish and every battle that took place that may have blocked a road at some point. There's, of course, also a variability of attributes. They change over time. We do have a temporal slider, but of course, we can't show everything. And in the end, of course, we are a historical project. We work with historical sources. So the work is also dependent on our interpretation of the sources, which is connected to the known problems. So what's our output? We have a fair calendar in which we have mapped our different fairs and in which we show the relations of the fairs to each other, hopefully showing connections between the fairs. We have a route calculator that I will show you more in detail in the next slide. And we have a database that is free to download on our website, and people can use our data to their heart's content, which we will come to later on. So this is our route calculator. It's just a preliminary function for now. So we know that people love our route calculator, and for now it's based on a Dijkstra algorithm, and it's only based on distance. If we get the time and the funding, we would love to expand our route calculator to something, as you could see maybe in the Orbis route calculator. We want to take into account economic routes, maybe pilgrimage routes. There is a little option on travel speed if you go on foot or with a horse or as a messenger. But this is basically, for now, just a little thing to play around with, and there's a lot to do still. What are the perspectives of Via Bundus? So first of all, we would like to expand geographically. For that, we need to find regional partners. For now, we are pretty detailed on the Netherlands, on Denmark and Germany, northern Germany. And we are still looking for partners in Eastern Europe and prospectively also in all over Europe, basically. So for this, we need to find partners first, and then we need to organize funding so this can actually happen. We would also like to expand technically and contextually. We would love to add sea routes, as these are really important for the Hanse, of course. Then there would be, since we only differentiate between towns and settlements for now, it would be pretty important to differentiate between inns, monasteries, and castles, so different types of infrastructure, which hasn't happened up until now. And then we would like to link our data to other open source data that is around. We would also like to add APIs, landing places, and so on. What else can you do with our data? So there have several people who have worked with our data on a network analysis basis, as you can see on the pictures here. And they basically just downloaded our files and played around a little. And there are already some little results. So there's one work forthcoming on the relation of fares, staples, and tolls, and how they might or might not have been the backbone of the economic medieval times. But also, Via Bundus has already been used as a museum application. So there's a map in a museum somewhere that people can play around with. It has also been used in schools for students to relate closer to their environment and to old roads and their proximity, basically. And what could also be done with the data is some gamification elements and, of course, center periphery studies on a more scientific level. So to conclude, what are we? We are open source data that anyone can use and play around with. We always need more data to be more specific. So the more data, the better. And in that sense, we need interregional and international effort. And if you should be interested to collaborate or have any input or feedback, please feel free to contact us via our email or just me personally. And that's it for the Via Bundus project. So thank you very much for your attention.
Thank you, Maria. See you after in the, okay, for the discussion. Okay, the next talk is by Gabriele Ciccone from the Itinerarium Antonini and Alidrisi to the MovCust plugin, study of the viability in the Castronovo di Sicilia area by comparing traditional sources and least cost path analysis. So, Gabriele, do you hear us?
Yes.
Okay.
Yeah. Just a moment, I share the screen. Oh, sorry. Yeah. Okay.
Okay, maybe we can move on and then. Okay. No. Okay.
Try again. Okay. You can see the slide.
Okay, we see. Okay.
Yeah, thank you. Good afternoon, everybody. I want to quickly thank all the ArcheoFOSS staff, especially Domizia and Noemi, for having me in this interesting panel. This is my first approach to this kind of spatial analysis. I'm very happy to present it in ArcheoFOSS conference. Today, I will show you a preliminary road network study in the Castronovo di Sicilia area. Castronovo has been one of the focus areas of the ERC project Sicily Transition. The main goal of the project was to study the archaeological remains of the regime change. And Castronovo area was perfect for this research thanks to the several remains from Roman to Byzantine, Islamic, and Norman Swabian periods. In this slide, you can see all the Castronovo sites studied during the ERC project. During my ongoing PhD project, the ERC results were integrated with an archaeogeography research, carried on combining traditional sources like aerial photo and historical maps with new methods like multispectral and thermal joint survey and different kinds of spatial analysis, of course. The list cost path analysis I will show you today started actually like a test of the move cost QGIS plugin. This plugin is made by Enzo Cocca using the algorithm made by Gianmarco Alberti for the statistical computing software R. So I started to test different functions for a list cost path between Palermo and Agrigento in the beginning, and then looking that there are not huge difference between the function I tested, in particular for path quite big like this one, I chose to carry on using the Tobler's on path tagging function that, for what I know, is one of the most used in list cost path analysis in archaeology so far. So I used the Tobler's function to calculate the list cost path that link the main centers of the Sicily coast. As you can see, I used Trapani and Marzano for the west coast, Catania and Siracusa for the east coast, and Palermo and Agrigento for the north-south path. The main goal of this first analysis was to see how far Castronovo is from the best natural path would link the coast of the island. The digital terrain model used that you can see in the left image is the one that the plugin automatically downloaded from the NASA Shot a Radar topography mission. Of course, I know this is not at DTM historically accurate, but I think it's quite good for this kind of preliminary analysis. After this first phase, I decided to compare the LCP analysis with more traditional sources that inform us about road network in this part of Sicily, especially the Itinerarium Antonini for the Roman period and Aldrisi's Book of Roger for the Arab Norman age. In the first source, in the described path from Agrigento to Lilibeo, is present the Stazio of Petrine that we identify with a Roman building founded in Casale San Pietro during the ERC project. And in the upper right corner, you can see the building during the excavation, while in the bottom corner are preliminary hypotheses of reconstruction made in Blender. To compare the Itinerarium Antonini with the LCP analysis, I referenced the maps made in CAD by Luigi Stangati, like this one. And I think it's quite impressive how the LCP overlap the Roman road from Agrigento to Palermo, as you can see in this image. Then I start to compare the distance of the Itinerarium Antonini with those calculated by Ugeri and those made by the LCP analysis. And what from the analysis that the distance calculated by Ugeri are more precise for the southern part of the route from Agrigento to Petrine, but less so in the northern part from Petrine to Palermo. And about this, I will show you why in the conclusion. Quite different are the results of the east-west path. I compared them with the Roman road network, where they look to really overlap only in the east of Enna, in the red circle on the left image, and with the transhumance routes that were an important connecting network between the east and west of the island until at least the 19th century. In this case, in the image on the right, the LCP overlap only in short obligatory sections, such as some mountain passes, like Passo di Patti, that you can see in the west part of the island. I also compared the LCP results with the Arab Norman road network, vectorized always by Luigi Stangati. And what emerges in this case is that there are more overlaps on the east-west route than on the Palermo-Agrigento route. Again, we will see an hypothesis for explaining this difference in the conclusion. Turning now to the Book of Roger, for this area, Aldrisi gave us a distance from Castronovo to 5 near centers that you can see on the right: Corleone, Raia, Prizzi, Camarata, and Sutera. I used again the Arab Norman road network map made in CAD by Stangati to observe how many overlaps there are in this case, and then to compare the distance of Aldrisi with the ones of Stangati and the ones of the LCP analysis. What emerged in this case is an excellent correspondence with the distance for Prizzi and Corleone, less for the ones to the south, and for Raia. About Raia, I think it could be a mistake of identification because the toponym survive in a location between Prizzi and Corleone, and you can see in the map. But Aldrisi localized the place between Castronovo and Prizzi. So in this case, I have a doubt if the error is in the distance reported by Aldrisi, which often happens in his text, or in the exact identification of the toponym Raia, which derives from Arabic toponyms widely used in Old Sicily. Quite different is also the LCP result to Camerata. In this case, the difference is probably to the crossing of the Platani River, which was supposed to take place further east near Casale San Pietro, where the Arabic toponym Cantara survives to indicate the presence of a probably Roman bridge. So I developed another LCP passing through Casale San Pietro, but comparing the distance, the result is not much closer of those to Stangati and Aldrisi. There is not a big difference with the first LCP I elaborated. What I think it's interesting is that the first LCP result passes very close to the place where the 16th century bridge and the current bridge of the SP26 road insist. It is therefore possible to hypothesize that in this area there was a natural ford to cross the river, probably used only in certain periods of the year, while the road that passed through the bridge near Casale San Pietro had to be the one that could be used in every season. In conclusion, the results of the LCP analysis seem to allow us to identify in the naturally good position of Castronovo one of the causes of his fortune as an important passing place during the whole period from the Roman to the modern age. Of course, just one of several causes, not the only one. Moreover, the considerable overlap of the LCP result between Palermo and Agrigento may be a further proof in favor of Stangati, which identified the route of the Itinerarium Antonini north of Castronovo, the one in black in the map on the right, and not to the west, passing through Corleone as claimed by Ugeri. You can see the green one in the map. The situation is quite different for the Arab-Norman network, where the LCP result seems to overlap much more for the east-west route. This difference with the north-south route could be due to a strong presence of Byzantine fortification that forced the Arabs to avoid the natural corridor of the Platani Valley for at least 30 years. In fact, the Arabs landed in Mazzara in 827. They crossed the whole south coast until they reached Syracuse less than 2 months. And then they will head towards to the northwest coast until they conquer Palermo in 831. But they will have to wait until 857 to conquer the Cassar, the Byzantine fortress of Castronovo. So all this could be the cause of a lower presence of Arab routes along the north-south direction of the Platani Valley, and therefore explain the difference with the Roman route and the results of the LCP analysis, difference that probably continued in the Norman as Swabian age. Regarding Aldrisi's book, however, the excellent correspondence seen before between the LCP results and the distance for Pritz and Corleone seems to allow us to hypothesize that the Arab geographer actually traveled west of Castronovo toward this center. And this hypothesis can be suggested also by the description of Castronovo, Pritz, and Corleone that are quite more accurate than those of Camerata and Sutera. But this is really on a preliminary hypothesis. In the next phase of the research, I'm going to integrate all the results present here today with other LCP functions. In particular, I want to try the Herzog and Pandolf functions that express cost as metabolic energy expenditure. And of course, I'm going to modify the NASA digital terrain model to get one more historically accurate. I want to also integrate the results with a study of the orientation of the portselling and with the analysis focus on the two different fortification systems of Castronovo. That is something I started to do just this week, and you can see a few recent images of this. Of course, now I want to try also the tool presented us by Anita in the introduction. And in the end, I can say that this preliminary LCP analysis gave me several suggestions to work on. So that's all. And as I said in the beginning, this is my first approach to this kind of spatial analysis, so I'm open to any suggestion. Thank you for your attention.
Thank you, Gabriele. See you in the discussion. So the next talk is by Marco Montanari and Lorenzo Gigli, and it's entitled Using Modern Standards in the Past, HTFS. We have here again Marco Montanari, who is a computer engineer, expert in artificial intelligence, who works to the creation of new technologies dedicated to smart cities, cultural heritage, and digital cartography. 8G. Eccola, 8G. Oh, ok. Qual è? Using l'ultimo. Eccolo qui. Ok.
Hello again. This project is by me and Lorenzo, the same person who I worked with for the study website, and a third person as well is Andrea Gentili, who's a researcher on in economy, because he was working on an analysis on the evolution of the economic aspects of the train, the economic influence of the growth of the train network in Italy on the industrialization of the country. So we started doing a huge work on Excel, but Excel is the deathbed of data. So, sorry. Here, no, yes. So, we started, as I said, we started working on Excel, but Excel is deathbed of data. So we started, at a certain point, we threw everything away and we started from scratch, looking at standards. And the best standard that could cover the data set that we were looking for was the general transit feet specification, which means that we have a set of elements. This is the general structure of the GTFS: agencies, routes, trips, stop times, stops, fares if they're available, and many other secondary information. As we will see, there are also additional elements that are interesting to cover. The main elements that we analyzed were agencies, routes, trips, stops, and calendars, which are the fundamental elements, and many of them were quite okay as data sets, because the additional information that we needed was not connected to those elements. Some of them were, in fact, to be modified, or at least we needed to add information or metadata to those elements. And specifically, this is some of the use cases that could be done with the situations where GTFS makes sense. As Anita said in the first in the introduction to the panel, GTFS and in general this kind of data structures helps a lot analyzing both the frequency, the depth of communication between places, and it helps also analyzing how to get from one place to the other. This is the normal use of the GTFS. What we're trying to do is exactly bringing back in time the same functionalities we would have today. So what were the problems? Agencies had no website. Duh. Agencies passed through several transformations. They do today, but back in time they were it was even more complicated. For example, Austro-Hungaric railways were a mess of interconnected networks that were completely crazy. Italian network were at least 4 different railway networks that were slowly integrated into one today that works perfectly. And the digitization process is complex, is immensely complex, because there is a lot of horribly unstructured data. But it's also possibly very detailed, because we will see a few cases, and in Italy we are very lucky that the Fondazione Ferrovie dello Stato is has already published all the ancient books, the timetables from 1860 to today. And we have an enormous mix of very high and very low granularity. So it's a messy situation. So based on that, we started looking and found out that the main changes were basically trying to keep track of what we were already digitizing and trying to reconnect that information throughout elements. But we started relying on we decided to rely on Wikidata to have a reference, a general reference to the main element. So the agencies don't have a website; they have a Wikidata item. The timetables have an agency, are connected to their agency ID, but also to the original document, the file, the specific file that is that defines that specific timetable. And then the specific routes usually have a Wikidata item associated. And if they don't, they could have, and it wouldn't be an issue, because it's usually important interconnections between between places in the world. Again, it is connected to a timetable ID, meaning that we're looking at that route in that page specifically, so that we can work back and find again where this specific number comes from, so that we can trace it to its origin. And so we found out, looking at this, it's a very not that much used, but a very interesting format that is called GTFS RIDE. It is a format that looks very specifically at the single ticket. It's used to do analysis of passengers in metros, in bus stations, so that you can see really how many people go through at a certain point. And lucky enough, we have a lot of specific tickets from, this is, for example, the White Star Line, so it's the Titanic. Luckily, somebody left it at home, or possibly didn't go that day, take the ship. But in general, it's a we have a lot of those information stored in several places, in several archives. So collecting these elements can be also a way to give value to those potentially almost useless objects, just to reconstruct how how the life was and how things were at a certain moment in time. Again, practical applications. We're using at the moment the trains from the Staatsbahndirektion in Trento and in Merano, in Alto Adige, and in South Tyrol, and the data from the Fondazione FS, which is, as I said, a huge archive from 1890s to 2020, with all the scans of all the connections, national, international, with all the timetables. One researcher is doing the transcription of every 10 years, but the idea is to go with the citizen science approach and try to fill out also the elements in between, and try to collect as much information as possible about that, about the data that is already online. For that reason, we have built a small platform based on Django and Django Ninja, which will be published in the next weeks as a platform with a pure API, and an Angular and MapLibre interface that will be published just after that. The researchers are using right now the Django admin interface. They're not that happy for that, but it's work in progress. If you need something fast, you get something fast. It's not going to be nice, but it's going to be fast. And on the other hand, we were trying to define with, in this case, luckily with a friend that works in UX UI, something more human to help users define the timetables, and to help them transcribe the data from the timetable, from the original timetables on paper, on scanned paper. This is one scan from the beautiful data set and the Wikidata ID from the various sources that we're collecting right now. So what is the future of the project? The idea is that to publish obviously both parts, front end and API, and keeping the API independent, by the way, is a nice step, because we found out there are no tools to do that, to generate GTFS files that are open and usable for the end user without a huge cost. Integration into open history maps showing the position of the described vehicles, ships, trains, planes. We already had the ships in the 17th and 18th century, but this will help defining additional positioning of elements on the map. And export everything as raw GTFS data, eliminating eventually the historical part so that they can be used with modern day GTFS information, and meaning that we can decide to see how a train would have driven from one place to the other in a specific moment in time, which is not a curious element right now, but it can be interesting. And by the way, obviously, the original question, research question, let's see how the industry was impacted by the evolution of the train network. Thank you.
Okay. So the panel is almost coming to end. The next and the last talk of this panel is by Paolo Rosati and is entitled Archeologies, a QGIS processing toolbox for archaeology spatial analysis. So Paolo is a postdoc researcher at DigiLab Sapienza and is on the board of ArcheoFOSS associations. He is currently a member of the lab and of the Archeo and Arte3D lab of DigiLab Sapienza. So, please, Paolo.
I am not here to destroy everything. Don't worry. Not again. Okay. Are we okay online? I have to. Yeah. Okay, so thank you for the introduction. I'm starting with the title explanation really soon. Archaeologist, a QGIS processing toolbox for archaeology spatial analysis. And of course, all of you knows what about QGIS. I'm not here to explain how it works and what is processing toolbox. We have a better definition, just because probably if you know what is QGIS, probably you don't know what is processing toolbox. Processing is an important tool of QGIS. It contains the complete list of the software's internal functions and the list of algorithms installed via external libraries and via plugins. Processing has its own tools, the most important of which are the graphical modeler and the Python console, useful to writing and implementing our own scripts in PyQGIS. PyQGIS, it is the developer language, the code, in which specifically we can code and programming with a Python sublanguage, QGIS. We can control all the function in QGIS using PyQGIS. It is a very useful, very useful library made by Gary Sherman, the founder of QGIS project, and then implemented by all the community. Archaeologist, a definition, actually is a experimental plugin for QGIS. It is in test mode, and you are free to clone and folder and install it. And please give me some suggestion and some suggestion. Tell me what you think about. And as a well, it consists of few scripts, but today we have only one tool. I am so proud of it, just because this is my first QGIS plugin. But really soon, I promise, it will implemented the Greek algorithm and the Persian algorithm. I call Eratosthenes and Darius. But today I want to show you how is working my tabula peutingeriana, which is an archaeological script. The inspiration paper about this my idea comes from this important paper from il Lazio tra antichità e medioevo, osservazioni sul calcolo delle miglia da Roma sulla tabula peutingeriana, in the volume Study in Memory of Dijan Cost, edited by Zaccaria Mari, Maria Sperandi e Maria Teresa Petrara in T2000. In this patient paper, Susanna Pessigli made some drawing on paper analysis, and this is the result. But we can have some problems with this type of approach, just because Susanna Pessigli makes a really interesting paper. And this study applies the extensive metrology studies conducted by the professor Carioli Fulvio Giuliani to the network of known roads of main vie consularis around the capital of the empire of Rome. Pessigli thus arrive at realistic reconstruction of the network. However, studies on the tabula peutingeriana are more difficult than the simple millage archaeological road juxtaposition. This because the tabula, it is a complex map, a complex document. It is an historical document. So first of all, it is a 12th century medieval copy of an original 3rd century Roman map. It reports a road situation that, even around Rome, is not linear. The roads of the tabula peutingeriana, in fact, follow the main roads, but very often the tabula indicated a secondary roads reaching important places, but off the main roads, of course, bypassing bridge that must have collapsed at the time, landslides, obstacles, etc., as we will see in a second moment, of course. The copy was made century after the original map and was drawn by a medieval amanuensis and was evidently often worn out, sometimes incomplete, so that some parts were completely made or summarized. From all that point, it can be deduced that the tabula peutingeriana needs a philologically careful reading in each of section to avoid misinterpretations. And now it is talking something about code. Don't worry, I am in the right place, maybe. Okay. This is, I will show to you the Tabula Peutingeriana algorithm PI. So I feel nude in this moment, but it is so simple. For who doesn't code previously, we have a heading in the right high part of the slide. Then we have the load of the main PyQGIS libraries. Then we have to create the class, return some translatable things or stuff, and then we have to create the instance. All these instances are for to put inside the processing tool of QGIS our plugin. It is so simple. And all the systems are really simple. The name of the output, the name of the script, the translated name of the processing group, the ID name, the help string, and then it is to initialize the algorithm. Choosing in the output layer the type, of course, of our input type of our plugin, which is the vector, and choose the input vector type, the lines, the name of the first output, which is Roman Miliaria, the name of the second output, Roman Milia, and then here we have the core of our plugin, our script. You can see that here I brought 1,418 meters, which is the result of the average of millage done by Carioli Fulvio Giuliani, professor of Sapienza University. 1 mile, it is 1,480 meters for Carioli Fulvio Giuliani. Sometimes more, sometimes less, but we are at the same. And the name of the processing algorithm used, it is above. And very quickly initialize the, okay. Then run the separate count algorithm. It is important just because I want to number the millage from room or from an important city. So the plugin, in the plugin we have to put inside a road network, and the plugin gives to me points. The points is the exactly positioning of the milestones numbered. So I can see this is the first mile, the second one, the third mile, etc., etc., etc. Workflow and methodology, it is really, really simple. From GitHub, download the plugin as a zip folder. Then in QGIS, open plugin menu, and in the main menu, click on Manage and Install Plugin. Choose the right directory where you put your folder, and then install the main zip folder. Push install, and experimental plugin probably, I don't know, will work. I'm working with, but sometimes could not be simple. And the methodology, it is really, really clear for using this type of plugin. We have to draw vector QGIS lines of our network in QGIS, of course, in every format you desire, and in every SRED you want, it will work. Ever from a starting area or point, each road must start from the center of your research. Of course, if your research it is on Antioquia, you have to start from Antioquia to the next point of station, or to the next city, the next village, the Vicus, Armand Vicus, or Roman Statio, or etc., etc. Okay, you have two main segments from your mainly road network center to the other point. Exactly how it is happen in the Tabula Peutingeriana. You can see here we have Piacenza It is a northern Italy beautiful city. And the Tabula Potingeriana, it is said to us 20 miles from Ad Padum, Padua. It is the second important Italian city. So here we will have probably 20 dots, 20 points. Each dot or point could be the positioning of a milestone. So you have to draw your network as it is made inside the Tabula Potingeriana. It is really simple. The Roman network must be made by diverse lines. Do not unite the segments. It is an important thing. From the processing toolbox, launch the script, and then this is a little result made in the northern Egypt area. You can see all the millage from Alexandria of Egypt to Cyrene in the actual Libyan. It is really, really important to know where the exact millage from an important city is. What is? It is simple. Why it is important? It is important for a sum of reasons. The first of all, it is that we can reconduct some important toponym exactly on our map. So Pempton, it is in Greek Penta, it is the 5 millage place near Alexandria. And it will be probably in this place, near the 5 point. And Naton, which is the 9th millage place, can probably is here, around the 9 millage place, etc., etc., etc. Then you can find, of course, I stopped my segment here near Taposilis Magna, just because in the Tabula Potingeriana, the first segment, it is between Alexandria of Egypt and Taposilis Magna. So you can see that here, from Taposilis Magna to Komaru, which is the other segment, the counting, it is returning to increase. 1, 2, 3, 4, 5, etc., etc. It is really simple. It is nothing of. Okay. In another way, it is important to reconstruct in the right way the network, your network. If you remember the third slide, or the fourth, I don't know, I show to you the original reconstruction of the Roman road in the early 2000, and we have a line with some dots, but it is not a linear reconstruction, the Tabula Potingeriana road network, just because we had some troubles. The Romans had some troubles, and then they can, of course, build the road inside or upon the mountains territory with troubles, and it is a photo, a picture of the Roman road network in the 3rd century. So it is not the reality. It is not the real, the original way of, in this case, of the Tiburtina Valeria. The Tiburtina Valeria, normally it is, yes, like that. It is working from Rome, and then it is go on the east countryside of Rome. But in the Tabula Potingeriana, we found that from Rome to Acquealbule, we have a segment, then stop. What the Romans do? The Romans, to go to Tibur, which is a really important city, starts from Rome, then Nomentum, then Tibur. They pass on the Nomentana way, just because the bridge was collapsed, probably, on the Aniane. Yes, I'm finished. On the Aniane river. This plugin could be useful to find milestones. This is a wonderful 36 milestone of the ancient Tiburtina Way, which is found in the center of the beautiful square of Archeology, a little village in the eastern countryside of Rome. We know that it is the 36 just because we read the milestone, of course, but we can reconstruct where this mileage was. Therefore, this fourth reason to, because this type of analysis it is important, of course, it is to find the original pathway of our roads. And this is a picture of the ancient Tiburtina Valeria road recently found thanks to the road analysis of archaeologists, and of course working during the 2022 survey. So thank you very much. I hope my presentation enjoyed you, and see you after at the discussion.
Okay, thank you, Paolo. So we can start the discussion. First, we have to look if there are questions by the online people. On Telegram, yes.
Okay, we have a question for Gabriele Ciccone by Guido Antinori. Okay.
Yes.
Okay. Can you highlight a bit further the type and quality of data you used for the least cost path analysis?
Sorry, can you repeat?
Okay. Can you highlight a bit further the type and quality of data you used for the least cost path analysis?
Yes, of course. Yeah, I used the tabular non-path tagging function and with the plugin on QGIS. It's quite simple because you have to choose really few details that you can change. But I think that are standard details for this kind of function in the plugin. So yeah, I can't choose more thing to difference for this kind of plugin. But I think probably is my problem because it's really a first analysis I made with this kind of spatial analysis. So I have to work on a lot. Yeah. All the detail I will show in the paper because are really numbers and other things like this.
Okay, thank you. So I have another question for you.
Okay.
Have you tried different types of least cost path analysis or only MobCost plugin? And
no, only MobCost. Sorry.
Okay.
Only MobCost for the moment. I won't try also the others, but.
Okay, thank you.
Okay, are questions from you in the room for the papers of this first session of today?
More curiosity because it's not your core, let's say, focus, but the parceling that you showed in the last slide, how was that determined? And how can it date that it's something related to which period? And how did you recover that?
It's made by the an old photos by 1946, I think, and then I compared with the data, the modern data, and try to understand if there is something medieval or is just of the modern age. But it's something I'm working on in this week, so okay. I can say more.
Or Roman, probably also imperial. Or you exclude it?
But I don't think it's. But I don't know. But it could be for the moment, I think that's more medieval or more modern age, but I'm not quite sure now.
So I have questions for Maria. So Maria, are there ongoing projects using the datasets by Viabundus? What is the point of the situation right now, and how is the impact of your work?
Yeah, thank you. So ongoing works, honestly, I don't know all of them, or if there are any. In fact, there are some people of ours who work on it. So this work I showed you on the network analysis on fares and tolls and staples, that's in print right now, which is pretty nice. Me myself, of course, for my PhD project, I'm thinking about working with the data in Viabundus. And apart from that, the beauty of it being open source is that we have no idea who's working with it right now. So last 2 days ago, or 3 days ago, we had a workshop where people presented stuff they were doing with Viabundus. And there are people in NodeGoat, I don't know if you know about them, a network analysis tool in the Netherlands who are working on that. And the data has been used in master's theses and so on. And we really hope that people who use the data also come back to us so we can broadcast it.
Okay, thank you. I have another little question for you. And what about the importance of have guidelines in the additional attributes in a project like this, if you have them in your DB? And I'm thinking about lexical differences in written sources, because me as a medieval archaeologist, I work a lot with geodatabases and written sources, so I have to collect data, but they are very different because lexical terms are different in a large scale study, even regional.
Yes, that's very true. Because of that, for our database, we kind of worked with a minimal amount of information for now, and we try to well, we don't try to streamline too much. So that's why we have the settlement category for a lot of attributes like castles and monasteries and so on, because it becomes very complicated. Thank you. And at the same time, also our word or toll, for example, is very broad. The general idea of toll is very broad. It also includes safe conduct, for example. So there are categories in medieval times that are very complicated that we for now try to keep very simple. And the broader the data gets and the more we expand, the more we need to think about that. That's very true. But for now, we try to add everything in form of comments and comment on that again in the documentation file. So if you really want to work in detail on it, I would always recommend on reading the documentation files that go with it.
Okay, thank you. I feel you for difficulties with medieval times and written sources. Okay. I think we have also...
Yeah, but I see that Anita is still with us. Anita, do you hear us?
Yes, I hear you. I hope you can hear me as well.
Yes, thank you. As you have seen, our research is very different from yours.
Yes, that's what I expected, but it's also very interesting to see the overlap. So I wouldn't have expected that you find a way how to adapt GTFS to ancient times.
Okay. Okay. Yes, I have a question for Paolo, but I'll see. Okay. So I was wondering, have you used Ancient Road Network for your plugin or not?
So, which is the question?
Ancient Road Network.
Okay. In reality, not. I suggest to use your archaeological data. The network have to be real or similar to near pathway of the Roman roads, and with the necessary minor errors you can have upon this pathway. So I do not use an ancient road network like I don't know, at the Dare, of course, the Dare network or something like that. I draw myself my pathway based on, of course, the archaeological data. A piedi, a Tiburtina. Ah, tutta. Un giorno. Let's do it together. Facciamolo insieme.
Question and also maybe a methodological issue. I found very interesting the contribution from the Polish colleagues, because there is an issue, there is a problem, a risk in, and then the networks that we are reconstructing apparently could be empty. There is no mankind in it. I agree. I was born as a scholar, as a migration period specialist. So one of my problems has always been that I always found moving artifacts, and to recognize the way people were moving is always being a difficult task. So on the one hand, to be able to figure out path and ways through which humankind is moving is very interesting and important, but we always have to bear in mind as archaeologists that men were moving on that. So I'm thinking how to, for instance, to integrate this kind of network analysis, this kind of special networking with other kinds of data on migration, DNA, isotopes, and all these things that are indicating the way people were moving from one place to another. And also, somehow, maybe going back to acknowledging archaeological culture. If we have to understand who is moving, otherwise, why a road network did exist on Earth if nobody's moving on it? So I agree that we are digging numbers. I'm fond about that. But on the other hand, as Sir Mortimer Weir was saying, we have to keep in mind that we are looking for people of the ancient times as well. So that's it.
Thank you very much for your comment.
So okay, we are, okay. We have a last question.
Yeah, I was wondering actually, maybe Anita, since you're a data scientist, do you have an idea? Because what we always deal with, I'm not a specialist on road networks or networks in general, but we always deal with gaps in data. So as you said, like, yeah, we have people moving, but a lot of, we don't know, are there people, were there people, they just didn't lose anything? Like, we have a lot of data gaps. So do you maybe have an idea how we can address those gaps? Because I mean, in the end, movement data is network data, and it's kind of like, at least in my opinion, it's kind of the same thing from far away. So yeah, that's my question.
Well, from contemporary data, we also have observation gaps, sometimes systematic ones, like certain areas where you don't have any observations, or just because the sampling intervals might be rather long, like you might not get a location update for a couple of hours before you see the next location that a certain person or other moving object might have visited. So there are methods that will determine the most likely path or the most likely set of paths that one person might have taken in between. However, if you have gaps in the network itself, then that's a different kind of question. We have something similar in case you want to merge graphs from different sources, like if you have a public transport graph and a separate graph for pedestrian movement, like on sidewalks, for example. They are usually not connected, so you have to find methods that can change from one graph to the other one to get complete routes. But the gaps between those two are usually rather short in geographical terms, geographical distance. However, I don't see why you couldn't also create apply those potentially to some of your questions. It really depends a lot on your specific question and the data and the shortcomings the individual data set has. That's what makes data science so hard. We so easily gravitate towards trying to solve everything with the tools we have, even if they are not really suitable for the data sets that we have to deal with. So it's a hard question to answer without having seen the data and the specific problems you're trying to solve.
Yeah, that makes perfect sense. I was just wondering, because you must deal with gaps, just probably with shorter gaps, or they're more
Yeah.
predictable than the gaps we're dealing with. Because I think a lot of it is based on geography, and most other network sciences, they try to kind of abstract that in a point where you just have the pure network, and the geographical aspect is kind of just ignored. So you're like, okay, we have nodes and edges, that's it. But actually, the geography is really important for us. So I was just gonna mention that.
Yeah, geography probably can help you as well, because that hasn't changed so much. I mean, the physical space around us, sure, cities have grown and shrunk and roads have been developed, but still the distances between places, the physical distances, they have not changed. The travel time changes, of course, with the infrastructure and the technology, but you can still determine which areas are more easy to pass, are used to be more easy to pass than others.
Yeah, I don't know, not my area of expertise, but I would argue probably where I was born and regarding my class, like I'm German, I would have probably not even ever been to Rome. So I think actually the distance in historic times does, like, the physical distance doesn't change, but the ability to go places, I think, has changed significantly. So anyways, I don't want to take up the space. So thank you very much. Maybe I write you afterwards. Thanks.
Sure.
We want to thank all our participants. Thank you, guys. Thank you, Anita. And we have now the coffee break. Okay.
The original program schedule, so we'll begin again at 5:15 in order to give the possibility to remote persons to follow us. Thank you.
Thank you.
Can you hear me? Can you guys hear me? Is it better this way? Okay. Okay, just tell me when we should get started. And... Is it better this way? I'm not sure if I can hear you. Can you say something, Julian? Okay, I don't hear you.
Okay, probably now it's okay.
Now.
Okay, great. Okay. My fault. Great. We're very tired, so we're looking forward for the.
It's been a long
for the
day.
end. Yeah, a long 2 days. Yeah. So please, would you go forward with the introduction of the panel and just a few words, and then we get started.
Yeah, sure. Hello, everyone, and thank you very much to all the people in Rome who decided to stick around for the very last panel of ArcheoFOSS. And also thank you to our friends and colleagues in the US who agreed to wake up very early to join this presentation. So the idea of this panel was basically born from many conversations that Julian and I had around historical maps and the representation of past places. And we both, noticed this shift in what maps represent in archaeology, from a tool that archaeologists use to record their work to actually object of our historical investigation in their own rights. And we see the number of digitized map collections growing in several libraries and cultural institutions, which is not surprising at all, as historical maps really hold a lot of information that is incredibly valuable for researchers in many disciplines and for different groups of people, from academics to member of the general public. And I think that it is exactly this richness of maps as historical artifacts and also as vehicles of historical information that explains and accounts for the many digital approaches that are growing around digitized maps, and that by no means exclude each other, but actually complement each other and enrich each other. So we decided to put together this panel to hear what other people are doing with digitized maps, and in particular with historical maps. And of course, the short presentation that we will have today will be not an exhaustive overview of what is going on around digitized maps, but more a way of start a conversation and compare notes about the common issues and maybe the common methods and the common good things that we can replicate. And we really wanted to stress that the digitization of historical maps is in no way the end of the process, but it's just the beginning. And of course, it is an important first step, but we would really like to see cultural institutions more engaged with researchers, with the member of the public in taking this process further and think more about the data and the information that we can get from maps and what happens to these data. How can we start having more conversations about ways of gathering and analyzing critically and sharing and documenting and communicating and preserving this information. So thank you again for joining the panel. You will see different approaches to digitize maps, and ideally, I hope they will be able to join us. We will also have two special guests for the discussion, Drake Zabrinsky and David Ramsey, that will offer an expert point of view as pioneers in making available large digitized map collections. Okay, so I guess we are ready to start with the actual presentations. May I ask the organizer later to also include my colleague Katie McDonough in the discussion at the end? Okay, perfect. Okay, then I think I'm actually the first, so I'll get started with the presentation of our project. I'm going to share my screen. And you should be able to see my slide now. Can you see the slides?
Yeah.
Perfect.
Perfectly.
Okay, so I'm going to start introducing very briefly the project my colleagues and I are working on, which is called Machines Reading Maps. And it's an international collaboration between the United Kingdom and the US. And let's say its focus is to use machine learning and semantic technologies to collect text on digitized maps. And why do we want to do that? Well, we want to make the digitized maps machine searchable, which of course will also make them much more accessible and much more reusable. And with this process, we also hope to generate better and more granular metadata for the single sheets that cultural institutions can then reuse to complement their official metadata. And last, but probably the most exciting for me as a humanities scholar, is that with this process, we are creating a new kind of research data set that can be investigated and explored and analyzed to answer humanities research questions. And we said it's a combination of machine learning and semantic technologies, but it's also a combination, in some ways, a collaboration between automatically generated data and manually generated data. So for the machine side, the tool we use is called Map Curator and is developed by our colleague Yaoi Chang at the University of Minnesota, and it's a fully automated machine learning pipeline. And what happens when a map image is processed with Map Curator is that Map Curator finds the text, so generates sort of bounding boxes around the words, then identifies the text, so attempts transcribing the text that it has found, like performing an OCR basically, and last linking the text, linking the words that have matches with external knowledge bases. And at this phase of the project, they have used data from OpenStreetMap. So what the human side of the project involves, well, we also wanted to create manual annotations. And for those, we relied on a customized version of a tool that some of you may be familiar with, which is Recogito. That was an annotation platform developed by Rainer Simon within the Pelagius project. And the first reason why we sort of commissioned a customized version of Recogito that was specific for annotating maps was that we wanted gold standard annotations. We wanted, good manually produced annotations to evaluate what the machine was coming up with and, check if they were good. But we realized quite soon that there was actually much more in this tool, that it was more powerful than just that, and that we could use it as a sort of magnifying lens to look closely at the text on the map, which is what we were focusing on, and see, what does the text on the map do, and how it interacts with the other elements in the map, how they together contribute to deliver meaning. And what was really crucial for us was that we were able to express and to share this information as structured data in a standardized, in a sustainable format, which is, the web annotation format that Recogito is built on. And the way that we collaborated with Rainer to redesign the interface was to be more able to capture these nuances. And we actually piggybacked on established semiotics and cartosemiotics theory. And one of the things that we thought was important was the ability to assign each of the things, of the elements that we were annotating manually on the map to one of these three main categories that we called entity, label, and symbol. And with entity, we meant, things that on the map that resemble things, in real life, like, for example, the footprint of a building. With label, we meant, mostly text, words, characters, and numbers. And with symbol, the abstract signs that we understand by convention or because there is an index. And what we were really, well, every map has a combination of those. Every map has each of them to different extents. And one thing that we were really happy that Recogito allowed us to do was to say that actually most of the elements in the map belong to more than one category because they perform more than one role. And that's because, maps are such complex synthetic text documents, and they compress so much information that every little thing actually means something. And that was the case of text as well, because with text, its value as a label is very obvious, it's very straightforward. So it's telling us the name of a place, it's telling us the name of a thing, either its unique name or its generic name. But actually, text is doing a lot more because it's also being used through the typography as a symbol. And it's delivering a whole lot of extra information that has nothing to do with the literal meaning of the label. So things like the size, the orientation, small caps, all caps, the use of italic, the use of bold, they all contribute to deliver extra meaning. And if you look at pretty much any map or any map in the Western tradition, we are actually very good at picking up these visual clues and consciously or subconsciously realize that some of these elements, some of these choices combine to define a type of thing on the map. Even just the difference between things that have a name and things that don't have a name, or in the example of the ordnance survey map that you see here, the fact that quite clearly street names look quite different. So for us, the question was, okay, if we can do that, if we can pick up those visual clues, can we get the machine to pick up those clues and help us actually identifying categories in the text on map so that we are able not only to search by string matching, but to say, okay, can you show me just the streets? So we asked our colleagues in Minnesota, and they said, Is it possible? Yes and no. And yes, it is already happening to a certain extent, because through that process of linking that we mentioned at the beginning, the text, the labels are already associated with some information that is sort of inherited from the knowledge base. And that is, enormously important for disambiguation, and, it enriches semantically the text on the map. However, the categories that come from resources like OpenStreetMap or GeoNames are not always the best fit for historical maps, and we are sort of, stuck with them, and we cannot change them. And, they may be completely anachronistic compared to what we want to do. And in addition, this process of linking to external knowledge bases only benefits entities that have a name and have a match, and those that are, still there, because often disappeared things are not mentioned there. And sadly, we don't have a good coverage yet of historical gazetteers. So the short answer is no, it is not possible. But we thought, okay, can we gather enough data to start, experimenting with it and understand better to what extent that will be possible in the future, and, if it is worth it. So we chose a case study to start gathering material, and our case study was the representation of antiquities on the Ordnance Survey maps, which are this nationwide mapping effort that took place in the UK in Victorian times. And we chose the antiquities because we love antiquities, but also because they were quite an interesting object on the map, because actually the level of accuracy of information about antiquities and archaeological sites on those maps is quite surprising for, maps that were targeting the general public. And also they have an interesting provenance, because that level of information, and we're talking about, the single find spot of a coin hoard, clearly did not come from the surveyor, but that information came from published material. But from a practical perspective, the reason why we chose the antiquities as our case study for these experiments was that they stand out a lot as a different type of things on the map. And they stand out visually because they have dedicated fonts, and actually they have dedicated fonts for each of the 3 main time periods that cartographers decided to focus on. And you can see from this detail that they are actually easy to spot on the map because of these quirky fonts. But they also stand out linguistically because they're often associated to keywords that only occur when these historical sites are mentioned. Words like site of, ruins, remains, find spot, supposed site of, and things like that. So our workflow is, we're going to run Map Curator on a number of OS maps and get all the text, all the labels. Then we're going to use these keywords, this dedicated vocabulary, to filter our results and hopefully create a data set of labels about the antiquities. And then we want to compare this data set with external cultural heritage data sets, some contemporary to the time when the maps were produced, and some that are more recent. And through this comparison, well, in the first place, we want to gather more data about the feasibility of automating this process. But also, now that we have the data, we also want to use it to ask archaeological, historical questions like, can we spot biases of, inclusion and exclusions of those sites? And also, can we use these labels to capture something that Carter theoreticians named Schlittmann defined peripheral signification, which is, that level of meaning that is sort of accidentally embedded in cultural artifacts, in our case, maps, and that they say a lot about the cultural context in which maps were developed and the worldview of the authors. So can we use these labels to understand more about, attitudes towards these heritage at the time the maps were made, or how the discipline of archaeology evolved through time, or how the interpretations of these sites changed? And we don't have the results yet, but we look forward to discussing them with archaeologists and historians. And we also had another case study, but I think I ran out of time, and I'm happy to stop here and just thank all the members of the team, which is an international team. And I'll hand it over to you, Julian, to introduce the next speaker.
Thank you, Valeria. Actually, I'm the next speaker, so it will be rather easy. Well, we're switching also. Could you stop probably sharing your screen? Okay, thank you. So we're going to switch now the scale completely from machine reading maps to something like amanuensis work with maps. I'm going to show you this this case of we call it a backward engineering of historical maps. So we come from a GIS background. We use data to create maps, and then we do the inverse thing. We start from a map and try to collect data of different value, historical and archaeological data. And the case of the 18th century gazetteer, the Napoleonic map of Egypt. This is a project that has been conducted here in Sapienza at Laboratorio di Archeologia Digitale, in collaboration, of course, with the ERC Advanced project directed by Paola Puzzi about late antique Egypt. But I need to acknowledge also younger people, students who gave a huge help to this project: Luigi Campagna, Cecilia De Leone, Ariana Giordano, and Alice Greco, who graduated a few hours ago. Yeah. So what is the Napoleonic map? It's La Cartographie de l'Égypte. It's a huge enterprise managed by the Napoleonic savants during the Napoleonic conquest of Egypt, but it ran shortly in very high difficulties due to the campaign, the French campaign, which is not successful, of course. Yet the French topographers did manage to accomplish their job and publish the map of the entire Egypt and also Near East in 1818, actually, not in with a mistake of 1 century, of course. We are much fortunate in here. It's also 1822. We're much fortunate because we have some metadata on this. The engineer, Pierre Jacotin, who made and published the map, provided us his memoir on how he did this, what kind of instruments, what kind of survey they used. And this is most of the time very helpful to us in understanding the map. Well, this project has been realized thanks to the disponibility of David Ramsey, who permitted the reuse of the scanned maps of the scanned book by Pierre Jacotin, available in his map collection. And of course, this is not an historical document that has never been studied before. Anne Godlewska, professor emerita at Queen's University, has published important studies on the historical context, on cartometric analysis, and thorough study about this incredible historical document. First of all, we use this for the Archaeological Atlas of Coptic Literature, so we needed to georeference it, use it as a web map. We published this as a Sleepy map tile names, a protocol known developed by OpenLayers, also known as X, Y, and Z. And we publish this in open data into our website, and of course we use this into our atlas. But nevertheless, this point out that's very important from the historical point of view. So we could do some more work in this, and this GitHub repository is the result of the next slides of the work that we have done on this. So the available data that I'm going to show in the next slides are already available on this GitHub repository for free for you to use in a manner very similar to what we what Deng showed to us before. And to give, let's say, a visual output of the state of the works, with only also maintaining WebGIS interface of the available data that's been, of course, updated. Well, georeferencing was not trivial because the projection is in meters, of course, but even meter is not the same the meter that we use as research from Anne Gotleska showed. The Napoleonic meter is different from our meter. So we need to fix this from a metrical point of view, and also we need to find ground control points to georeference the map. And we had some uneven results. Some of these sheets are highly precise from the metric point of view, and others for different historical reasons are not that good, of course. Well, at this stage, we have focused on two items: on hydrography, that was important to us for the studies of late antique Egypt, and on the gazetteers, so in place names. At the end, I'll show you what remains to do, of course. Well, hydrography is much important for Egypt, as we know. The Nile is the reason why Egypt exists. So the different the historical changes of the river are quite different to understand its landscape, both for settlement and for transportation, of course. So we had a thorough digitizing of all items related to hydrography, and we're trying to document the metadata of our works in the let's say attributes of the vectors that we have found. So we've been digitizing and defining typologies from different kinds of river and canals, and also for the areas like marshlands, ponds, dams and bridges, and etc. This is most important for the reconstruction of the landscape. And we'll also define a rather, hypothetical way of typologizing the different kind of canals. It doesn't mean that it's strictly represent the picture of the Napoleonic time, but it's a way of categorizing a datum that we cannot describe thoroughly, actually. But I want to focus a little bit more on the gazetteer that we have digitized. Actually, we have manually digitized. That was I called a amanuensis methodology, almost 3,500 unique polygons identified by Ubiky, possibly refer to geonames identifiers, 1/3 of them. And all of these are reporting text labels of the place names as they are reported in the original map, both in the French romanization version and also in the Arabic script, because in most cases the original map reports both of them. So this is it has been copied as it is, just to provide the historical background. From this, let's say, version 1 of the gazetteer would try to reconcile these places to actual places. So we have tried to somehow translate specially the places of the Napoleonic maps to the correspondent location, geographical locations of these places, the current coordinates, in order to have virtually a georeferenced gazetteers. Basically, we've been using geonames.org as a current days gazetteer, but it has not provided all the time to be the best solution, of course, because many things have changed. But we are in a very fortunate position here because we have some other historical maps that helped us in filling the gaps. One of these is this edition, the century here is right, published in 1914 by the Ministry of Finance, which is a modern, let's say, standard cartography, very precise in terms of metric and georeferencing, and also in terms of place names. So we use this also historical information as a mid-solution in order to try to position and to find positions of place names that were mentioned in the Napoleonic cartography into current days maps. Nevertheless, this doesn't solve our issue because we have a lot of place names that we are not able to identify today, because many of them have disappeared in time. Many of them have moved both physically and in their place names, not only on the location of the village itself. So this is a kind of hypothesis that we can do. We could call it Gazetteer version 2.5. It's to use a kind of statistical approach. So to use vectors of known places that we know that for whose we know the original and the destination coordinates, and to apply when these patterns is let's say recurrent to unknown places in order to be able to provide current geographical coordinates. Well, this cannot be done for the entire map, but for particular sheets like this one, this can provide, of course, some good solution. This is a statistical approach. It doesn't, let's say, tell anything about the history of these places through time. Well, a very last attempt that we have made on these places is to provide reconciliation with other historical gazetteers. So one of the most interesting actually projects is the World Historical Gazetteer, which is a collaborative effort creating, let's say, an IT tool, an IT platform for the putting together place names, historical place names from different parts of the globe, and try to guess a reconciliation. So they are trying to build linked data based both on toponyms and on geographical positions, so in coordinates. Well, of course, we know historical gazetteer most of the time do not have geographic coordinates, but our map for most of the places does. So another attempt that we are trying to build is to keep and take each of the versions of the gazetteers that we have produced and put into this, let's say, common effort, and try to have some automatic reconciliation between places. Sometimes this have offered very good solutions. We have 30% plus place names that are being identified. But this is something that needs to be checked by human, because as we know, place names are most of the time recurrent. So you find the same name applied to several places in geography. In this case, coordinates, geographic position can help in providing some key, of course, for the understanding or at least for evaluating the let's say the validity of what the machine has to offer. Well, this is a collaborative tool. They have also developed a data model that embeds also information on chronology, because as we know, not only geographical position is important, but also chronology. We cannot put together data coming from different time periods. So it's most important from our point of view, since we have a very clear chronological indication, to have a specific time frame to use for the reconciliation of these records. So virtually we are producing different versions, or better, let's say, different branches of the same gazetteer, each of them having different historical values. This is valuable from the historic point of view for those who are interested, for example, with the Napoleonic campaign of Egypt. But it's also important for the study of the Egyptian landscape, because as we know, in the 19th century, Egypt has undergone also, of course, in the 20th century, important land transformation program that has completely changed the layout of the country. So it has been proved to be most valuable tool also for archaeological purposes. Well, but this is just a starting point. So we've been working on this for a year now, or a little bit more probably, not full time, of course, but a lot of information is still waiting to be extracted from this map. The most important is the road network. We've talked today many times about the road network. We've presented a road model, a graph model of Egyptian late antique roads and movement last ArcheoFOSS, but we're still waiting to extract, for example, the road model, which is represented into this map, and to confront this with information that we have from, let's say, Roman times, or also from pharaonic times. That would be much important. But also other kinds of infrastructure are very important, both from the historical point of view, but also from the archaeological knowledge of the country. This is but a simple list that has been extracted by the work by Godlewska of what remains still to be extracted. It would be very important, for example, if we would be able in the next months or years to put together a collaborative effort in order to let's say, fully reverse engineer this kind of maps. And this is a methodological, let's say, point of view important for us, because it permits us to look at this kind of documents from a quite different point of view. At least in archaeology, we've been using historical maps from long times, but also this has been something very task specific. What we try to do is to datafy this kind of document and to provide to the community information, let's say raw data, even if this is a little bit interpreted data, but with, let's say, cheat sheet about the methodology that we have followed. And when trying to explain this, because it is important to evaluate also the precision and the validity of our work, which is not all the time 100% clean. So a lot of work can be still done, but of course some bias remain on the historical data. Well, there are different ways to deal with them, but it's important to share this information with the broader community when we offer the data as an open repository on GitHub. So this is more or less, in broad terms, the project that we are trying to do. Is we came to a stop now due to internal, let's say, organization, but it would be most interesting if it can find some external help and put this together in a collaborative way and provide some more information about this, and also Middle East, because we have left away the part of the Napoleonic part of Syria and etc. But this is also part of this historical document that still waits to be evaluated. So this is the point that reached so far. Thank you for your attention. Okay, stop. We're going rather fast on the schedule. So Marco Montanari for the last time on our final. Okay.
So, so one last time. Hello, everyone. We started for we need to talk. We will need to talk after that. Basically, we started looking at two problems, which is in the next slide. Map warping for vectorization, meaning we need to create new vectors, exactly like Julian just explained, and we wanted to create a geospatial gazetteer. We started from this point of view because we had maps that were a bit older than 18th century or 19th century maps, because of city level detail. And as such, we started looking at the process. As I said this morning, for me, the core element to keep track of is the process. So we get the source, we digitize the source, we create the control points with QGIS typically, and we warp the image and verify the warped image and validate if it matches the real world structure of the city or of the area that we're looking at. On the other hand, to create the gazetteer, we look at the same point. We start from the same point of view. We get the source, we digitize the source, we have this image, the beautiful image, and then we create labels, like Virginia earlier said about like Valeria said before on the data we have. At that point, we need to reconcile the names with sources, and then we export the gazetteer. Beautiful. There are two different processes, but why can't we just start looking at them with looking at the points in common and find out where they get some difference, where they transform into something different? So we both processes start from a source, from an image, from a digitized image, a digitized map, and they both define points with labels or sharing them with other maps, modern maps, old maps. This is a detail that we will look at. Then something happens to those points, and then we can export the result of the transformation. So why can't we just start from the same part and transform the label creation, the labeling, and the creation of the control points into one only operation that stays in the middle in a different way? So we create labeled control points or unlabeled control points and reconcile them in real time with external sources. For this reason, we created, with the screen we had before, we create an object that is a known place. And every time a user on our tool clicks on one of the points, the user clicks on plus, and it creates the first point on one side. Then he clicks on the same point again and says, okay, this is the label that is associated to this point, because, for example, it's a 17th century map with all the labels of the important places in the city. And this way we have a first element that gives us a first level of data quality. After he clicks on, after that, he also is able to say that if it is a control point or not. Maybe it's just a labeled element that is no longer visible in the modern map. So it's just a point that is labeled in a certain moment. So it goes into the gazetteer, but it won't get into the control points. And basically, from this point of view, we are able at that point to click on the other side, assign a control point if needed, and we create a structured table with all the control points, be real control points or labeled objects with a control point, and we associate them with this. In addition to this, we associate them with their OpenStreetMap and Wikidata objects, so that we can already connect them to the other information from other sources. And from we can then download the resulting object as World Historical Gazetteer dataset to be imported into the WHG database. So this enables us to do in one single operation many of the aspects of the transformation that would typically be required to transform a map into something that can be reused in a different way. In addition to this, we can run the transformation, and it generates the pyramid, the image pyramid, to be used as background for other reuses. So the more points we have on the map, the more the transformation is precise. The better transformation, the better we have a pyramid. The better pyramid, the better it is to reconstruct additional information. In addition to this, we can use all previously created pyramids as backgrounds for georeferencing. So we have this map in 1580, I guess, more or less. And we can connect this to another map of 1570 or 1590 and see if a point was there already or changed right in those 10 years that were more or less the time frame in which the two maps had a difference. In addition to that, well, exactly, this is a map from an area of Naples that changed a lot. And all of these are all control points of the system. The system, exactly. The exports, as I said, are the pyramid that can be exported directly as GitHub package to be used as static information, blah, 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 blah. It looks like sometimes I feel I repeat myself, but yeah, but in the end, I think the value of these projects that we create in completely different areas, in completely different with different teams, with different ideas behind, is the fact that we have to arrive to a point that we create something that is standardized and that is reusable by somebody else without a huge effort. It's just a tile collection. It's just a set of folders with images. That's it. We don't need to reimagine the wheel and reinvent magic stuff. It's a folder with files. So it's a zip file, so it can be stored on GitHub and made visible with a simple static visualizer. And so we create this. We create the data is published on Zenodo. We discussed with Grossner of World Historical Gazetteer, so that we can add the column of, because the idea behind this tool is, as I told before in the other panel, is to be able to give citizen scientists or passionate people the possibility to do parts of the digitization. And as such, we can keep track of all the collaborators and contributors to the single gazetteer page, meaning that if you are a researcher and have your ORCID ID, you will be connected to that specific line of work, so that your work is kept track of. And at the same time, if you're not a researcher, but you're just a person that creates an account and wants to work as well, it's kept track of as well. And there is a way to retrace the origins of all the passages. And again, the idea is also to the system also stores the data on Zenodo, giving the possibility to transform at every iteration, every addition of elements to one specific set of points, a DOI that is updated, that is versioned, and so that we are able to track from the image all the transformation, all the data points that are connected to that image, and then all the reuses of that specific gazetteer connected to one image with other more broader analysis and transformation of the data set. Thank you. It's been a long day.
We're running fast at the finish line. It's all very, yeah. But I would ask, calling here my colleague from Sapienza, Sara Leonardi. This wouldn't be possible if we didn't have open access repositories with historical maps. So probably this is most important project to researchers trying to read this kind of.
Good evening. My contribution is just a little bit different.
because my project is at the beginning, and because I don't speak only about historical maps, but my approach is a geographical approach, and so I speak about geodocumental and cartographic heritage. My participation to this section is aimed to illustrate what is going on in the newly established Museum of Geography, the 19th Museum of Polo Museale Sapienza. The museum was officially established on May 2022, but we are working on this project since 2012. The process has begun with the emergence and cataloging of the geodocumental and geocartographic heritage stored in dusty drawers and shelves of the geography section of Library of the Modern Letters and Culture Department of Sapienza. The heritage consists in ancient and historical maps, negative plates, globes, and other geographical ancient tools. And we are convinced about the considerable interest of it for research in general and for geographical analysis and studies in particular. It was collected by geographers who taught from 1877 in Sapienza as a result of their travels, exploration, and didactic excursion, or such as lesson material. One of the principal aim of the project is share this geodocumental and geocartographical heritage with all those who have interest in using it. For example, in the analysis and interpretation of iconographic and cartographic source to study the dynamic of the territories. In fact, the geohistorical heritage is an important tool to study the territorial transformation, to know changes that have taken place over the years. So, keeping in mind the good practice of accessibility and participation in the cultural heritage aimed not only at the simple promotion of the heritage, we, as many other colleagues, consider fundamental to value the cultural, social, and historical dimension of the geodocumental and cartographic heritage to promote a conscious participation in order to use it. Our project started from the glass negative plate, and we create a website to enhance and make known this heritage. To the website, we attributed different functions, such as local archiving or a dissemination tool, research virtual place. To simplify, the website currently online can be defined as a web storage mapping, and it is a dynamic theme archive with a geohistorical path. The architecture of the entire system was developed by the Geocartographic Laboratory of the mentioned department, and it is the combination of a series of hardware device, virtual server, storage data, and a content management system. Throughout the work, particular attention was paid to the organization of the data, for now consisting just in digital negative plates transformed in various steps into web-based format, reduced in site and super composed with an element of watermark graphic. The access is free, the images are free, but we are pleased to know who will use these images, the use made of it. Our standing idea was to build a simple database, but suddenly it was replaced by the more ambitious project to realize an online system to manage a database composed by image, map, and textual context, data about geographical area, the image description, geographical position. To do view and query with the addition of a cartographic representation of the original place with a typical approach web-based mapping. To do this, we choose to use Drupal, a content management system that answers to our needs. Altrue is a system not specifically platform dedicated to digital cartographical representation. It was extensible to provide to mapping that can be adopted to every different need and specificity. The particularity of the digital archive is that the subject represented on the negative glass plate are geolocated and subsequent placement on a virtual planisphere here. In summary, therefore, it can be said that the architectural model of the web storage is something between the simple categorical display of the image and the more complex geolocalization with mapping of the point and the fundamental dynamic management of an archive of plates, image, and in the future with the map that will allow both continuity in update and the creation of new content online. Among the reasons that led to opting for such portal is to be part of an assembled whole, easily manageable and reproducible. Therefore, from the hardware and software point of view, a system able to satisfy behind the simple archiving also the spatial research based on geolocalization. This procedure is useful for two principal reasons. To search by subject directly on map and the second one for the territorial contextualization of the image imprinted on the negative glass plate. The availability of geodocumentary and cartographic source is a formidable vehicle for the study of territorial transformation, as I said before, and maps and geographical documents allow us to embrace space and visual embrace that is fundamental to the design, to manage, and to govern a territory. To date, more than 1,000 negative glass plates of more than 5,000 preserved have been included in the web storage, but we have 10,000 maps, ancient maps, that have been subject to restoration, digitation, and metadata intervention for about 10 years, with the aims of fully recovering their cultural value, activating practice of reuse, and giving a new meaning which allow an effective and complete patrimonialization. The university museums, such as the Museum of Geography, with their heritage, are cultural place, so they are the protagonist of the cultural offers, and for the reason the project has to bring out the heritage, restore it if necessary, and enhance it, otherwise it would be lost, integrate the resource of the archives of national and international level by creating heritage heritage network, and so on, build a network of living labs among scientists, but also open to practitioners and heritage institutions. Thank you.
Whoa, yeah, here we are, back again. So, please, should you put on the screen all the, thank you. Oh, great, yeah. So Valeria, do you want to stimulate some, conclusive thoughts? Maybe our, yeah. Yeah, we can't hear you, Valeria. Valeria, we can't hear you.
I was muted. I wanted to thank our discussant. Thank you, David and Drake and Katie, for joining us. And thank you to all the speakers who shared their project with us. Well, as we anticipated, quite different approaches and quite different ways and scales to look at digitized maps. One thing that two things that really struck me from the conversations that we had, the presentations that we had, where the growing importance of historical gazetteers. I think that many of us either touched on them or actually actively worked improving the available ones, and the let's say the opportunity to involve the community in what we're doing and in the what Julian called the datification of the maps, but also the valorization of maps as pieces of cultural heritage. So I would like to ask our guests if they want to touch on any of these issues. I see that David is having some problems with the audio. I don't know if the guys on the backstage can help him.
Okay, yeah, best. Turn off and turn on. It always works.
It's the old trick. It's the old trick. That's gonna work for sure.
Yeah.
Okay. Can you hear us now?
Yes, I can hear. Can you hear me?
Yeah, perfectly.
Yeah.
Yes.
Oh,
yeah.
oh, sorry about that. All right.
No worries, and thank you for joining us. I know it's quite early for you. So does any of you want to comment on either the role of historical gazetteers or the involvement of the community? You can take your pick according to your personal taste.
Sure. Maybe I would lead off. You can hear me okay now? Yeah.
Yes.
Wonderful set of talks. Really enjoyed them. And it made me think about what Drake and I have tried to do with my map collection now for over 20 years on Luna online. In regards to archaeology, we've always been aware of the possible use of historical maps in archaeology. And the challenge has always been how to, we are open access, everything is free, you can download, but how can you find it? And particularly as the collection has grown, as Drake remembers, from 2000 when we launched it to now over 117,000 maps and related objects. How do you get there? We are good librarians. We created categories. We have an archaeology category. It only has 250 maps now, and the obvious ones, Lanciani's Rome, the Napoleonic maps Julian talked about, and so on. We have other categories. Historical, I think, has 5,000. Classical has 3,000. But we're so excited about the project we're doing, Valeria and Katie, with you guys on machines reading maps, because that's going to open up a whole new way to query our collection for toponyms, town names, and go beyond the general categories that we've had. You'll be able to find individual towns, places, and again, with the tools that you guys have developed with Reiner from Pelagios, be able to annotate and add information over time. So I'm very excited about this, the role of these historical maps for archaeologists. Particularly the 19th century seems to be especially rich with the Palestine Exploration Fund big map. I know when we put that on 10 years ago, we had just anecdotal evidence from archaeologists that it was hugely helpful in identifying ruins that are not shown on any other maps. So hopefully this can grow and continue when we launch the new service in March, I think we hope, of next year, to be able to search the maps by toponyms. And Drake, do you want to add to that aspect of it?
Well, I guess I could add just saying that we're making good progress. We're actually starting to import the GeoJSON data, and that actually is starting to see the tags we saw it in a couple maps, and now we're going to see it in maybe even next week for our internal purposes. Some of the real live information from the maps. I mean, it's very exciting to see this coming forward. And I mean, that's something David and we've been missing. It's like a gap that's been there for such a long time to be able to get to all the gazetteers and all those place names, trying to find something in a map when there's the level of work it takes to do it manually is overwhelming. I mean, as I think one of the earlier presentations said, they did thousands of references in a single map, and we're seeing millions in it through the machine reading project. And it's a really amazing thing that's actually taking place. And I think it'll be, as it enhances and as people take it, and like David was saying, make use of Reiner's tool to augment and update and clarify this information, it's just going to be a great resource. And that's what we really want to make it is a better resource so that people can really access this stuff at a detailed level.
Thank you.
Probably a question for Kate and Valeria. Currently, this project of yours, the labor needed, the manual labor needed to clean the data, I think it's going to get lower with time. But currently, where are we?
Valeria, could I say a couple of words to kind of follow on from Drake, and then I think that answer to that question follows on, and we can both answer that. So yeah, I mean, to kind of speak about what we're doing on machines reading maps, and of course what other people in the room there are doing to think about the information that has been curated on these maps as you know, products of collecting information about place and space over time and around the world. It's really exciting to begin really just digging into these maps as really complicated, layered sources of information. And as Valeria said, there's kind of the intentional messages that the maps are trying to send, and then often, you know, these unintentional or the peripheral signification of maps that can be quite valuable to archaeologists and historians and others. And I think, just to come back to Valeria's point about creating gazetteers and having a way to understand the changes in place names over time and between languages, between cultures, is really invaluable. And I think that's kind of, it will hopefully be a byproduct of what we're doing on machines reading maps, with the data that's machine generated and then sort of curated by the users who come to the David Rumsey catalog to view and annotate and validate. So I think this opening up of the process of data collection to in a platform that is going to be extremely accessible, we hope. That's one of the things that we're going to be testing over the next few months. Will allow us to begin understanding the time, right, and the labor aspect of what does it mean to, rather than starting from scratch and manually annotating a map, like, you know, we've seen today, and I think lots of us have done in QGIS or ArcGIS. What does it mean to start from the machine-generated predictions of, just for the purposes of machines reading maps, the bounding polygons around text, right? So that is, I think, what's quite exciting, is to see what in a sense the cognitive process is like there. Where are the barriers? Where does it seem easy? Where does it seem hard? And how do we design for that? And I think it's also worth mentioning just quickly, right, the ethics of collecting this information publicly and openly, and of course sharing the data that we're collecting openly, which we're really sorting out. It's a bit different from volunteer geographic information. There's a lot of literature about that, where people are kind of grappling with, you know, the ethics of using information that people create through social media use or things like this. But this is a very intentional contribution to information about, you know, what's on the map. And so it's a really interesting space to be working in, and we're thrilled to be doing it alongside David and Drake and our colleagues at Minnesota. So yeah, I hope that starts to answer the question, but we're going to find out is probably the answer to your question. But Valeria, is there anything you want to add to that about the annotation aspect?
Well, no, not really. But maybe just that it also depends a lot from the map, because, you know, on some maps we will have better results than other maps. So of course, you know, it's like correcting OCR. With some very clean, you know, fonts, you will have few manual corrections to input, but if it is, you know, maybe an historical book, there would be more errors. So it really depends a lot. Of course, there is a component of manual work that needs to be taken into account, but it is variable, and we still, you know, are trying to understand what is the ballpark.
Yeah, I would just add, it's going to be interesting to see when we launch it. Just from our preliminary look, we've had accuracies of 50% on some maps to almost 100% on others. And of course, as you would expect, it's the very early maps from, say, the 1500s that have the 50% rates. And the 20th century is quite accurate, almost perfectly so. But you know, we've had now 12 years experience with georeferencing on my site. And I noticed, I just wanted to see today where we were. And we've now over 60,000 maps have been fully georeferenced, and it just grows hugely. So I'm optimistic that the crowdsourcing of these corrections will be really interesting to people, because it's a huge learning opportunity for people who love maps to go in and, you know, see these places and learn about them and then help us in the process. So I think I'm optimistic. And as we've said in our discussions monthly, well, 50% is 50% more than we have now. And so, you know, that in itself will be huge. And as Drake said, these are going to be millions and millions and millions of toponyms that are sort of the unsung heroes of our maps, these small places, forgotten ravines, all kinds of names that can bring up these maps. And so, you know, we're very hopeful about it. Yeah, I would just add for Julian, we just finished putting online the entire almost 1,000 plates of the Napoleonic Egypt, the description of Egypt's at 800 pixels per inch. So there's a lot of amazing maps in the plates, in addition to the atlas, of course. And we rescanned a second copy of the atlas, also at 800 pixels per inch. But I think you're done with that project for now. So
no, but for the moment, yeah. I mean,
yeah.
It's a huge work, of course, to do. But if we have a machine approach, I mean, then still we need reconciliation to be done manually, because place names are important. But if they are just text labels without meaning, we need to add some meaning then. So and then that would be great. Thank you very much. I know if there is any question or comments from the room. No, very tired. Well, thank you very much for being here. Well. Ok. Ci siamo. Possiamo andare.
Thank you. Thank you to everyone who stuck until the end. Thank you to our discussers.
The end of ArcheoFOSS, and if I correctly understand, we'll meet next year in Turin. So looking forward to that. Okay. Thank you, everybody.
Thanks,